Right. Hello. We're back. More kast. All right. Today I want to do the functions in the language need to be implemented again. Yeah, we did this before, obviously, when we had the implementation of camel x plus x. Let f is x plus x. Din, 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 din. If I use std, there you go. All right. I had that working before, but I need to do this again because we are re-implementing things in Rust. I'm going to do it a little differently. But let's see. First, what do we need? What do we need? So we have or I guess we just do x. Let's just try with this simple function, the identity function that just returns the thing immediately. Okay, so we want the function definition stuff to work because that's what the syntax corresponds to. So let's go here. Let's have function def, right? All right. Function definition. So what do we have in the function definition? How's Journey? You're first. Hello. You are indeed. In the function definition, what we can specify is we specify the argument, which is a pattern, where then we can potentially specify the return type. We specify the body, and another thing that we can specify is the context. So there's like 4 things that we can do potentially here. Dun, dun, dun. All right, yeah. And some of these things might be absent. So I'm just like thinking that I need some helpers. What I did before was what is the other thing that had something optional like this thing? I try into single named and then into named. You know, what I want to have is I want to have what? How about I have a more generic thing for my tuples? So a tuple is a thing that can have a named and unnamed fields, and but I'm expecting a certain set of fields when I'm doing the compilation. Some of them might be optional also. Like I think I want to have some more generic things, something like into. Let's see. Const n. Let's see. Unnamed usize. This is amount of unnamed fields that I want to have, maybe. Then named fields is another things, and then optional named optional is another thing. How about that? Result. So we will return the amount of unnamed things, right? The amount of named. Wait, can I have the const to be anything? Wait, I'm not even sure if we can do this. Hold on. What can we do with const generics in Rust these days? Can I do something like struct foo a, like if these are all simple things, abc, can I just have function foo which has a const f of type foo, and then I could like print f maybe, right? Debug function main foo a1 b2 c3. Can we do this or not? So I guess over here, since this is a constant, we need to wrap it in the these things. Foo is forbidden as the type of the const generic parameter. Yeah, okay. The only supported types are integers, boolean and char. Okay. So Rust cannot do that yet. This doesn't even link to the tracking issue of something. I thought this thing was coming, but I guess not. Okay, whatever. Whatever. And we do this. Result. So we have unnamed, we have named, and we have option t named optional. So those are the three things that we get, and then we have the error like that. So this is the more generic version. So right now I had the things that could convert this into named or unnamed only, but we want to have a combination maybe sometimes. Right. Into fixed. I don't know. I don't know how to call this. Let's call this into fixed, because this is where we fix what is the structure should be, I guess. So we want to have unnamed is just like a constant, yes. Named, so named things is strings like that, and named optional is another string named like that, right? There you go. Okay, let's have the errors. I will potentially remove these then, because if this is a more generic version, then no reason to do these things. Into fixed error. So I've erased things. So expected fields, right? This is specifically about the unnamed. So I have expected unnamed fields, and I have expected named fields. Neovim Craigasm, Noom VNR, hello. Expected named fields is going to be what, like back ring, I guess. Optional named fields is vec string. So this is what we expect basically, right? And the reason is going to be into fixed error reason. So we have this. this is going to be into fixed error, like that. Named error is going to be replaced with into fixed error. Self. Okay. Let's see. So since this is an into fixed error, we didn't or not expect only named fields. Right? There is like, this is the things that we expect potentially here. So so fields. Yeah. So we need to say what we expect here, right? Expected. Let's just say over here, right? F expected, right? And let's write out what we expected, and in the end we will write but got these things, right? Okay, so what did we expect? Let's see. Let started is false. Let start. If started, then write f. Oop. Else started is true. Okay. Why is this so smooth? Because it is very smooth indeed. Because I'm not just running NeoVim, it's NeoVide. I should make this a comment in my Kuvi board, I guess. Let's see over here, NeoVide. Oh, we don't have this here. Let's do this. Text commands. Smooth. No, let's just call it NeoVide. NeoVide text. NeoVim is NeoVim it's made smooth with the power of NeoVide. NeoVide. There you go. It's a front end for NeoVim. It's not running in terminal. That's why. I need to restart the bot first so that it works. There we go. Okay, this is mutable. All right, so what we have is we say if expected unnamed fields is not 0, then I will say start and I will say that write this many unnamed fields, right? Expected unnamed fields. Then if self-expected named fields is not empty, right? Then for row fields. Do I just go for um name in self-expected named fields? We just say start, and I say just write name like this, and then I say if self optional named fields is not empty, then I will say optional, right? Then I will say optional. Can I say here start it is false and then start f? No, I cannot because of course. And optional all of these fields. Okay, I mean here it's going to be easier. We can do index and name in self optional named fields, iterate, enumerate like this. If I is not 0, then wait, comma, and then we write the name. So optional these names is what we want. A space in the beginning here. Okay, there we go. So this is listed everything that I need, everything that I got. Well, I mean, in fact, you know what? I mean, the optional fields are not supported in my tuples. Tuple is something that we have actually. Yeah. I think I will eventually want to support optionals directly. Okay, whatever. This is good enough. Good enough. So let's see here. If self and if self, and this also needs to have self. Yes, as an argument. If self unnamed length is not equal to unnamed, then we return error. So we do these things into fixed error. Hello, Nigel. Incorrect amount of fields. Incorrect amount of fields. Expected. Async. Yeah, we're going to write some async today, but first I'm working with my tuples here. Into fixed error. Reason. Incorrect amount of fields expected unnamed. Actual is self unnamed length. Right. Okay, otherwise in the end we will say unnamed is a self unnamed try into unwrap, which specifically is going to be t unnamed, right? So we convert this into an array instead of a vec, and we don't unwrap, we just do say okay unwrap, I guess. So we ignore the error. So we return okay, unnamed, named, and optional. So yeah, I guess I could, instead of named optional, I can just say optional here, I guess. Yeah, into fixed error. Expected unnamed fields, named. Expected named fields is named iterate map string to string select. Optional fields is optional. I just call this optional. Halloween month. Yeah, happy October, I guess. 1. It literally just says 1. Wait, hold on. Is this it just says 1 to me. Tuesday 1. This is the new bar that I installed recently. I never really looked what it shows to me. Over here it has selected 28th of September though for some reason. This is weird. Is this float? I don't know. I just imported some settings of some other dude for this bar. I did not customize this myself. Okay, unnamed, named, and optional. So now for the named. Now for the named is going to be just clone. Erased value. Nix is funny like that. Well, I mean, you don't need to use Nix to just import some other dude's configuration. You can look at other people's dot files and import their dot files. Like, it's just a little bit more work, I guess, if they didn't use Nix. Yeah, I want to customize this. Like, there are some things that I don't like. For example, these icons for all the windows. You see, like, these are all the windows that I have. And all the icon is this weird icon. Like, why don't I even have the icon for the Firefox here? That's weird. I think. Looks like a bug to me. I need to look why is that. But I'm too lazy to do that. I'm not even sure that I need the list of windows here. I think I can just remove this completely. Alright, let's see what do we want here. So this is me figuring out the unnamed. Next, I want to figure out the named things. If so we want a combination of this, right? Named field present. Incorrect number of fields, unnamed field present. So this should be like incorrect amount of unnamed fields specifically. Expected this many unnamed fields, got this much. All right. Named fields present, I think this is not necessary. Named field not present and named field unexpected, right? This is what I want. Named field not present name is going to be something like name. All right, so field name is not present, and then we say named field unexpected name, then and we write field name was not expected. All right, that's it. So now we need to say, let's figure out these errors one by one. So if something is unexpected, it means that it's not present in either named or optional fields, right? So if self-named order iterate any name not named, I guess we just like say find. If we find name where named contains name, as string. So if name does not contain and optional does not contain name as string, if we can find something like that, then we return error named 100. I have the auto completion here. Expected a reference to stir on stir. Sure. Named field unexpected name to string. Sure. So this is if something is unexpected, and then if something is not present, then it means that if named any, if let some name is named find name which is self-named does not contain the name, name is yeah, like this. Then we return error to fixed error reason named field not present name to string. Okay. Then we say let named is named dot map name self-named remove name unwrap. Right, so this is going to be an array. Yes, and then optional is very similar. It's just optional map name self named remove name without unwrapping, because these things might not exist, right? Optional. Option T unnamed. Wait, optional. So this amount should be optional here, right? Yeah, and now over here we have a partially moved value. Let's just have the erased value to be constructed in the very beginning, maybe. Let erased value be that self map as ref, I guess, first. There we go. Very complex type used. Okay, how do I make this not so complex? Okay, let's have this to be a fixed tuple with unnamed named and optional, right? Struct fixed tuple const unnamed named optional. So instead of these three fields, we just say that unnamed is this, named is that, optional is that, right? So I need also have t here. So fixed unnamed named optional t, like that. Okay, nice. So instead of having a tuple here, we just say fixed tuple unnamed named optional, like that. Nice. So now I can remove the previous things that were less generic. The unnamed and named errors. These things can be completely removed, which means that over here we can say into fixed error still. I'm just going to use over here. So like if I want to convert it into just a tuple of unnamed things, then we will say self into fixed, where we have the empty list of named and unnamed, right? Question mark dot unnamed, and I say okay, and I think this should figure out the types automatically. Yeah, so this is really easy now. Okay, nice. And this is into named without any optional things. We just say in self into fixed where names are names, optional are none, named. Hello there. Okay. Instead of named error, we say into fixed error, right? But this does not know what the amount of unnamed fields we want to have here. So the amount of unnamed is 0. Other things should be inferred, like that. Types provided when a constant was expected. Can I have the auto inferred other arguments if I have multiple const generics in Rust? Gardienka, hello. I don't work a lot with const generics, but this seems annoying. So like I cannot use it, like underscore means automatically infer the type, but I cannot use underscore where a constant was expected. Can I say this? Or something? Underscore can only be used in the left-hand side of assignment because this is an expression. Okay. All right. So hold on. Rust underscore for const generics is not usable. Allow const underscore, this thing, yeah. No, not this. This constant underscore is a different thing. I want it to be inferred, right? So like the only way for me to get it inferred is that I don't specify any generic arguments. So like if I use the turbofish to specify the first thing, I mean, I know the other things, but like these could be inferred. Okay, I mean, sure. Let's say that this is n and this is also 0. 0 optional. But this is annoying. Into single named is going to be the same stuff. To shit. Into fixed error. We can have another helper, public function into named with optionals. Turbofish sounds so silly. I'm trying to remember the silly names of other things in other languages, but I cannot remember. Yeah. Rust is a silly language, I guess. Did you know that there's a website for it? Turbo .fish. Did you see this? So into named opt is going to be same like and use size const optional use size like that. Names stir n optional stir n. This will give me result t n and int optional and into fixed error. And okay, hold on. Let fixed tuple unnamed is an empty list, named and optional to be equal to self into fixed named names. And optional names question mark, and then I say okay, named and optional in a tuple. There you go. Expected array this, found array that. Yes, because this should be of size opt. Duck typing is also silly. Yeah, I agree. Cowboy coding. Programmers who write code according to their own rules. They may be very good at writing code, but they don't generally follow standard processes or policies. Interesting. I thought you were into duck typing because you use the GD script, which basically is like the language like built around duck typing. No, or do you use like the new type system that they added recently, which I heard something like. But you hate GD. Okay, so you use it, but you hate it. All right, got it. Got it. The type system is not worth using. Yeah. So I was about to say that I heard from Bad Cop that GD script, if you try to use the type system, it makes your code actually behave different, which is very weird. Give it a few years before they before they get rid of GD script and replace it with an actually good language, or what? what's going to happen in a few years. You think GDScript is okay? But the type system is very early. There was the new Python release recently, right? Python 3.13 or something. What's new in Python 3.13? Is that the recent one, right? Where's the date? Where's the date of this shit? 23 May. No. What's the latest Python? Python latest release. I know that they added something, but I didn't look at what they added. Do you know? Status of Python versions. 3.14. Okay. Wait, hold on. No, 3.13 is in the pre-release. I thought it was released. 3.13. Pre-release. Abstract. Release schedule. Lifespan. Copyright. Python 3.13 type system. New features for you to try. You've never used Python types? I used them a little bit. Although on the code base that I was trying to work on last time I was working with Python, I was working in the code which was written by other people. They were just annotating their methods to return dicts, and that's, I don't know. It's like, if in JavaScript you say that every function returns an object or something like this. Can you even annotate in TypeScript that you return an object? I'm not sure. Classic strong type dict. Yeah. I that's probably, I don't know if the reason that I hate Python is that I have been working with code bases like that or something. If someone was to actually use the Python type system properly, would I actually hate Python then or not? It's a relatively new feature, not a lot of people use it, right? Cool new features. Let's see. Better error messages. Better error messages. Division by 0. Look at this. It's nice. I need to do. Yeah. I need to do this in my REPL too, so that I highlight the number. I highlight the thing. Like this. Yeah, this is good. Pre-threaded. No global interpreter lock. Null is also an object. Experimental JIT compiler. Look at this graph going up. Improvements to static typing. So what did they add? Type defaults. Narrowing in types with type is. Typed dict. No way. No way. They added the typed dict. So there's the classic strong type dict is going to be much stronger now. I thought type dict was in the thing before. Well, I mean the way it will. I tried making it work in that code base. I think you made your it's literally, instead of returning a dict, I was returning my own class with fields. So yeah, and by having an actual typed dict, you can leave the code as is. You just change the annotations, right? So this is more like structural typing, in TypeScript then, right? Typed dict, and you can annotate this. Yeah. Seems like it. Not going to read through. Marking deprecations using the type system. So many things you can do. A random command line. The command line is coming with RNG now. Built in to the command line. HTTP server is now built in, so you don't need to do python-m HTTP server. Oh, you just add more command line options to this, I see. Everything should have RNG built in. I don't know. I mean, on one hand, yes. On the other hand, I sometimes think that like everything shouldn't have anything built in. There should be something that is like standard, but it should not be built in. That's what I think sometimes. You know? Convert the identifier to the uppercase, opt. Wait, what? Do I need to do this? Convert. Oh, because it's a const. Alright, makes sense, I guess. Ah, and renaming didn't actually work. If through the code action. Alright, Rust language server could be improved, it seems. In std or something. I mean, it's not, yeah. Maybe in std, but like std, like, I don't know, like in Rust we don't have random number generation in std, but it is in a crate, which you can very easily add to your, like, to your project. I don't think it's much difference. If it was something in std, then it means that it needs to be like backwards compatible forever. So it has like downsides to it too. You know? If it was in std instead. So I don't think it matters much if it is an std or not. It just should be easy to add, right? Easy to import. Convert. So like all of these should be converted. Unnamed. Named. Optional. Optional. Just do curl. Does Bash have as the RNG in the standard library? Can you do RNG in Bash without accessing the file system? Through the dev RNG. And without using the curl. Unused variable. Okay, so I was doing this. Let's for now. Yeah, I was about to like do the function definition. I was distracted by making my tuples work a little bit differently. A into B. There we go. Not yet implemented. 304 over here. But if I try to say like hello, it works. Native print hi. Print hi. All right, nice. So everything still works. Let's just do tuple. More flexible tuple into fixed. Okay, nice. If you access a random and it generates a new one every time. Oh yeah, really? What if I have an environment variable called random? Hold on. Hold on. Random is 1, 2, 3. Bash. Random. Command not found. 2255. Oh, it's because... Okay. Yeah, but what is the range here? What is the range of this? Then it breaks. It doesn't break unless you do unset random. Oh, is random always an environment variable? What about Zash? Zash, I guess, is the same, right? So we say unset random. Random. Wait a second. When I unset random, it breaks my syntax highlighting in Zash. Look at this. I try to type random and it becomes invisible. What? Well, that's pretty random, I guess. All right, nice. Okay, so I want to implement the functions today in kast. Right, so in order to have functions, we want to do this. Values. Let's ref into named with optional fields too. So the names that I expect to be there is actually the only thing that I expect to be there is body, you know. So body is the only thing that actually is mandatory to define a function. All the other things are optional. So wrap with macro received incorrect arguments. Optional fields are going to be so args, right? std syntax. Let's take a look again. Yeah, we have args, contexts, result type. Args, contexts, and result type. There we go. Body, args, contexts, and result. Okay. To do. We also need to once again assert that this is an expression that I'm trying to do. We're going to return okay compiled expression, where the expression is so we need to construct the function definition, which is like making a function expression, I guess. That's what we call it. Data is span net. Here you go, YouTube. I read the entire bash manual by Bashcop. 5,000 views. First cop to actually read all the material they enforce. Watching this on 0x25 speed.
Random. Each time this parameter is referenced, it expands to a random integer between.
You know what you should do? You should have like the time codes for the important bits of the manual of the bash. You know how you can like make sections in your YouTube videos, right?
0 and 32,760.
Where's the audio?
Assigning a
Oh, it's muted. You probably heard it.
Value to this variable seeds the random number generator. If random
Oh, you can seed it too?
is unset, it loses its special properties.
So it's a short, right? It's 2 bytes.
Readline argument. Any numeric argument given to readline command that was defined using bind-x when it was invoked.
What does it mean view in SSL? What does SSL mean here? Is your viewer SSL? What does this mean? You read the manual from the W3M browser? W3M. 88 days, 15 hours. That's the uptime of your PC. What's my uptime? 69 hours. That's nice. That's pretty nice uptime. Okay, so we need an expression, which is a function, right? Function expression. So function expression is something that needs a little bit of something, right? Function expression is something that constructs a function. Maybe I should take a look at what I was doing before. I mean, it's not that hard. Lib types. All right, let's see. Pum 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 pum. Instantiate no. Function. Fn. Fn is. Okay, there it is. There it is. This is what we need to know about the functions. Okay. I'm going to do it differently though. So as you can see, the compile, like the functions are they start by being not compiled, and then I only compile them when I actually need them to be compiled. We're going to do this differently this time in Rust. That's why it's going to be done differently a little bit. We're going to compile them as soon as all the information is ready. Instead. Shared compiled args. Kast template type. Okay. Maybe I don't really need to look at what I was doing before. Let's just think about it. So we have arguments, context, result type. These are ASTs. This is AST representing our arguments, right? Which might be absent. And we're going to Nautilus, good morning. Hello. So we have body, args, context, and result type. These things need to be compiled. What if you made a concrete syntax tree instead? It doesn't matter for compilation, but I will, I guess, do it because I want to have the formatter for the code, right? So this is a function. This is a function. What about an abstract syntax graph? Instead of a tree, just make it a graph. Interesting idea. Is that what you would do if you were writing something like that? Cyclic syntax? Yeah. Imagine the spaghetti that you could write by allowing cyclic syntax, right? That'd be nice. Are you doing the Ludum there, by the way? Are you doing it solo this time, or are you looking for a team bad cop? You think you want to do it? You don't have time? You're too busy working? Is that what's happening with bad cop? You quitting the job on Friday, so you're pretty free? Nice. So technically, the body is the AST that needs to be compiled, right? So we have something like self-compile AST, which is the body, right? And this is the compiled body, right? This is the compiled body. Body is an expression. Did I switch from OCaml to Haskell to Rust? Yeah. I was not working on Haskell version for very long though. Haskell made me rage quit. Trying new languages basically. uh, yeah, it was very annoying. Not because of the monads and everything, but because of some stupid things. It feels like, I don't know. You have a language you could try next? Which language? Lord T Gamings, hello there. The next language that I think would make sense to try is Scala, actually, because I have like seen a bunch of good things about it, but I'm not really into trying languages anymore. Not for a while. Some point maybe. Okay, so technically we compile the body, right? But in order to compile the body, we need to have access to the arguments here, right? So arguments is a pattern, by the way. So arguments is a pattern. Self compile pattern is compile AST. Just try the language in LaTeX, and if it's good, people will implement it for you. Oh, you mean like write a paper about the language instead of writing the language itself? Yeah. The academic way. Oh, there's also like the middle ground where you write something, not in LaTeX, but like in general. You write about the language, and then you advertise it before the language is actually done. Try to push everyone to know about your language. You know, have you seen the V language? I think that's the approach that they take. If you have seen these before, you mean Carbon? No, Carbon I think is something that exists actually, right? So like they don't really like do false advertisement of things that are not there, do they? Carbon language main repository. Like or is it not working anymore? Is anyone using Carbon? Fast and works with C++. I think I heard about Carbon once and that's it. Like when they first announced it or something. An experimental successor to C++, maybe this is when. They're still calling it a demo. Alright. Yeah, I mean, there is the road to 0.1 in 2024. But I did not check if they like, I don't know. I just remember like the V language because there were like they were promising a bunch of things, but then nothing actually worked, and then they were like removing the things from the list of promises like as the implementation went further or something, and then they still advertise more things that they actually do, which is like weird a little bit. Which is kind of like similar to how like the Mojo language, right? The Mojo kind of doing the same. Right? Hello? The website even isn't even working. The TLS handshake to the JavaScript delivered net. Powerful and easy to use feature. Is this what you were like usable yet. They have like this ownership plus borrow checker, and if I understand, like they want to do something similar to Rust, but it's not really there. But they have this very cool website. Get started now. Wait, is it actually working? Why is their website so slow? Create a new project using curl. Curl some magic. Some random hash into bash. Sure, sounds like a good idea. Value lifecycle. Ownership module. Memory safe without manually managing memory. In out. Borrowed. Compared to C++ and Rust. The module compiler implements a lifetime checker that ensures the values are not destroyed when there are outstanding references to them. Small values like int, float, and cmd are passed directly in a machine register instead of through an extra indirection. This is a significant performance enhancement when compared to languages like C or C++ or Rust. So they are actually faster than C. Mutable arguments. Arguments exclusivity. Enforces argument exclusivity for mutable references. Transfer arguments owned and that. Transfer sigil of the variable that is passed to the function. Curl is a random thing that adds typos to your bash RC. Wait, did you try this? It adds random things to my bash RC? I think it's not going to be able to modify my bash RC. Or is it? Bash RC. Wait, I have a bash RC actually. No, and it's not sim linked into the NIX. So it will be able to do that. But you run into this before? Okay. Anyway, I'm not looking into it. Why am I doing this? No idea. Okay, so arguments is an optional thing. Is an optional thing, and if it is not existing, then the pattern is going to have like it's the unit pattern, which is nothing, right? Okay, so I need another pattern, a unit, which only matches nothing. Self unit data. Collect bindings. Unit. This just does nothing. Init. If it's unit, then pattern unit. Data is pattern data. So so if I'm trying to pattern match against a unit, then it means that the type of something that I'm matching against is a unit type. There you go. That's easy. All right, let's work on this thing next. Unit. So what's the span though here? What is the span? So that I could refer to it. Let's have this original span. maybe. Mismatch types, expected pattern data. Yeah, because I need to initialize this. Question mark is only there. Yes, of course, of course. So I guess we do this, and then I unwrap, and then I transpose, and then I do question mark. Well, I guess we unwrap, or we do this, and then we just question mark. Try wrapping the expression in OK. Wait, what? Is the init? Yeah, it's because the init function should actually return the result here, right? Like this. Select bindings. If it's a function, then we don't have any bindings. Yep. Show short expression function. 8 function expression. Expression function data. And function data. Initialize expression function span to do. This over here is to have a question mark. Okay, evaluate function expression is a to do, and do a pattern match. So when I'm doing the pattern match of the unit, then I mean it should just always pattern match. We can make sure we can like assert that the value is a unit here, I guess. Other than that, not much else to do here. Okay. Back to the compiler. Okay, so we have the arguments. Arguments is a pattern, body is an expression, but the body is an expression which should have access to the bindings of the pattern, right? So we have something like self enter scope, self, oh, it's interpreter, enter scope, self interpreter exit scope. Before we compile, collect bindings. Where is it used? Pattern collect bindings. Yeah, we just do this thing, right? Very similarly. Over here. So we collect the bindings of the arguments. So everything that we introduced in the arguments is going to be available inside the body of the function. There you go. Yeah. Nice. Context is something that we don't really use right now. Result type is optional. If it's not specified, then it's going to be inferred. Context I will just ignore for now. Right. Context, we just ignore this. Do. let's figure out what the result type is. So the result type is something that we are going to evaluate. Maybe even like using the arguments here. So we say that result type is result type. You know what? How about if I, instead of mapping, I will actually just match this here. If it is like some args, then we try to compile the args. If it's none, then we say that this is a pattern unit in it. I think that's better. And similarly, the result type is going to be a match result type. If it is some type, then some AST, then we're going to self evaluate this AST. So the expected type. So we expect this to be a type, right? So this is some type. That's what we expect from the result type. And if it's none, then it's just a new inference variable, I guess. Type infer. Wait, where's my autocompletion? Inference. Oh, is this because I'm recording? I accidentally go into recording a macro in Vim all the time. So something like this. Result type should be not a value, should be a type. So this dot eval ast I call it expect type dot expect type. Okay, so now we want to know the type that the function returns. We know the arguments, we know the body. It has been compiled. And we now just say that this is our function. Wait a second. Wait a second. So I have already compiled the function here. Let's see, compiled is compiled function. We have the compiled function is like the only thing that we really need to compile here is the body, right? That's the only thing that's like going to be late compiled, kind of. But the type of the function is function type. We already have that available. So we have the argument type is so this is the type of the pattern, right? So this is going to be args dot type data type result is result type. That's what we need. So pattern, let's also have the data method here, which does not require mutability. Like that. And we go into the expression function. Function needs to have a function type. We need to have the compiled, which is going to be compiled function. And then what is a compiled function? It is the body, which is an expression, right? Which means that compiled function, let's say that this is boxed. Function type, does that not need to be boxed? Public. Wait, why does that not need to be boxed? Oh, because it's only types inside. Okay, whatever. So this needs to be boxed. Consider cloning the value if the performance cost is acceptable. Yeah, the type itself needs to be cloned. True. Okay. So now here, when I'm initializing the function of this type, and this is the compiled function, right? Then we say expression function, type, compiled, data. Let's just say that data is expression data. Since this data is span, we need to have the span information here, but we also want to have the type. The type of this expression is a function type, where the type is the type of the function cloned and boxed, I guess, like that, right? That's all I need. What else here? Yeah, this is evaluation of the function pattern. Okay, let's try evaluating the function. Wait, like it's weird. It's weird. Wait a second. How did it work before? What about the expression? Function? A function. Compiled. And type. Well, I mean, I do need to have the in the compiled function. I do need to also have the the arguments, which is a pattern. This needs to be here, yeah. Arg. I call it args here, but let's just name this over here. Dun, dun, dun. Let's call it arg everywhere, because all of my functions are functions of a single argument, including the std syntax. Instead of calling these args, I will just call it arg, right? Everywhere. What is this targs? Whatever. Template argument, I guess, is what I called it for some reason. Okay. Unused variable compiled. So when I evaluate the thing, which is a function, right? Then it means that I need to construct a value, which is a function. Right? And I need to capture the current environment too. That is something that is not going to be very easy. I need to actually redo my scopes a little bit, I guess, so that I can share them and shit. Okay, let's skip this to do for now. Let's go into the value and say that one of the values that I have is a function, right? A function which has the so a function has what? We have the compiled function, right? We have the compiled function, but we also want to have. Wait, what's the problem here? Recursive without indirection box. We have the compiled function, which actually means, you know, let's store this in an arc because I need to like do this here anyway. Compiled function. Let's write the bug on it. Pattern drive bug. Wait, pattern does not implement debug, but I literally just did it. Because pattern data is to implement debug. Expression. Wait, do I even need to have debugs? Not using this, but whatever. Let's see the equality of functions. But anyway, before that, what is a function? The function is something that is like compiled, right? But the function object, I mean, these are more like closures. So we have a captured environment in addition to the function itself. So captured is something. So like, what do we capture here? What do we capture? I think we capture a scope. That's what we do. But like scope is something that that I need to have here. Scope over here is what we have. So I need to like redo my scopes. My scopes should be able to be shared, in which means that instead of a box, I will use arcs here, and I need to use interior mutability. So the locals would be more like a hash map. Or I mean, maybe like I mean, I can get a mutex here, sure. Ever. Import mutex. Arc collections hash map. Sync mutex interpreter. Didn't find hash map. Wait, why not? Oh, because I imported it in main, not in lib. Lib. Arc. Mutex. Use std collections hash map. Scope. Scope is in the interpreter. Let's import this. Use interpreter scope, which means that this thing needs to be public there, right? Public scope. Okay, sure. Nodex new. So the scope that I have over here also needs to be an arc. Then, right? Get locals. So if I want to get a value, it's more like I need to clone it anyway, I think. So we do locals lock unwrap get cloned, right? Or I guess, I mean, yeah, let's just do it like this, sure. Over here we do arc new scope new self locals. So this is in iterator for the completion candidates. Say yes. So these are the locals. Let locals is self scope locals lock unwrap, right? Well, I cannot really move there in this case. Okay, so this means that I will remove this lifetime here. I think it's okay. How about we just do this? How about we just do this? I'm just going to like collect this into a vec, and then convert into iterator again. There you go. Yes, remove lifetime, let them die. Yeah, but this is not this means that I'm like doing unnecessary allocation now, so technically this becomes slower when I do this. Hello, Devninia. You hate lifetimes. Why do you hate lifetimes? They are very useful. Or is it that you have a skill issue with them? You just hate life in general? Alright. Scope get. Okay, so this should be like a value cloned, sure. I'm replacing the scope with a new scope. And then this is going to be like the parent. Right, like this. Cannot assign data in an arc. Yeah, indeed. Well, I guess, okay, sure. Look at this. How do I... My Vim is broken. My Vim is broken. Vim is bad confirmed. Like, how do I close this thing? How do I close this auto-completion thing? Maybe I need to start completing again? There you go. Okay, so this is going to be self scope is arc new let mut scope is scope new scope parent is self scope clone that, right? Semicolon. Self scope is an arc. I need a sum here. Have I ever tried Go? Yes, I did, but I mean I did not try it for a very long time, I guess. Maybe that's why I hate it, but the limited time that I had in Go was not very nice. I'm a hater. I'm a hater of that language without even trying that language for a very long time. WQA and code dot. He loves Go. Yeah, I mean, I secretly love Go, but we need to hate something for the fun of it, right? So we choose to hate Go. У тебя хороший английский, не знаю, по правилам, можно ли тут писать так. If you struggle talking in English, then, I mean, you can write in Russian, but I'm streaming in English, so since you understand it, it would be much nicer if you talk in English, so that everyone else can understand you too. I just hate it on stream, and secretly off stream I'm writing only Go. Yeah. My issue with Go is the same issue that I have with every language that advertise themselves as a simple language. Simple language is actually hard language. When I read any language advertise themselves as a simple language, it means that they are hard. Because when they say simple, easy to learn, I read limited and hard to use. Because learning is not really like an important aspect of a language, I think. Not the most important one for me. Use DeepL, Google Translate. How did you know that I'm Russian? Anyway, do I know you? Did you know me before you came here? I'm streaming in English. Why would you, or is it obvious from, I don't know. No, I don't think you can see that I'm in Russia. Just click on GitHub. Oh yeah, sure. It is written there where I'm from, I guess. Indeed. Scope parent is this. Mismatch type scope, found this. I need to return scope here. Is my balcony warm? Right now, yeah, right now I have I'm actually considering opening a window. It is 29.7 degrees, which is pretty hot, you know, which is pretty hot. It was 0 this morning here. I don't know. Outside right now is 19 degrees, and inside is 30. So yeah, I'm a little bit sweating on my chair right now. Ugh. I also realized with the balcony and the flowers, it's kind of a mega obvious. Is it only something that Russians do, or is the people in other countries, they don't have balconies? I don't know. CIS? Commonwealth of Independent State? Into. So scope parent, take inspect. Okay, so we just say self scope is a self scope parent, take expect. Not take, clone. I guess. There you go. Okay, and insert local would be self scope locals log unwrap insert. There you go. No method extend, because this should be log unwrap. What else? Interpreter scope does not implement debug. You know what? I think we don't need debugs. I'm literally not using debugs in anywhere. Do we have a function A and a function and function B? Then whether they are equal is what? I think just AID is equal to BID is what we're going to have here. Is that it's literally the same function. Why isn't debug default for everything? Because not everything needs to be debugged. No. Function score false. Actually, let's just say A is equal to B. So let's say that the function contains a function. How about that? like similarly to how native function contains a native function. Similarly to this, we will have a struct function, and function has these things captured and compiled. We need to derive clone for it, I guess. We will also have the ID here, and then we implement partial ACK for function. They are equal if the ID is equal to the other ID, and that should be all that I need. And close the limiter over here. And egg for function. Non-exhaustive display for value. If I want to display a function, then do I just write the function type then? I guess, right. Have function and function type, maybe. Which means that I also need to have the type here, which is function type, stored inside the function, I guess. Derive debug. Let's remove the debugging. Expected. Oh wait, but it should derive. It should implement debug for it to be an error. Yeah. Okay, you know what? We're going to derive debug for a value through the display. Impl std fmt debug for value. We format this by std fmt display fmt self f. Let's do that. Bam. If I am if I have a function f, then the type of this is a function type of the function type. There you go. I need to clone this. And I need to box it. Sure. Cannot write into value function. Oh, because okay, because this is formatter. This is let's call it function here. Because the formatter, maybe I should have called the formatter fmt or something. Whatever. Okay. Okay, I mean, things seem to compile. There is a to-do somewhere, right? So if I say x into x, this will say not yet implemented at 169 in an interpreter. 169 over here. So yeah, when I try to evaluate the expression that tries to construct a function, right, then we need to construct a value function, right, where we have a function with these things, right? So since this is a new function, we are going to have a new thing, new function. Captured environment is self interpreter scope clone, right? The type is going to be the type of this function. Type clone. Compiled is compiled. Compiled is what? Compiled is box compiled. Actually, it should be not the box. It should be an arc here, because I want to share it. So we say compiled is compiled dot clone. There you go. It's been a while since you was last here. How is the casting going? I don't know where was you the last time, but as you can see, we're writing Rust. Maybe last time you were here, we were writing this in OCaml. So I'm rewriting. There was also a short period of time where I was trying to rewrite it in Haskell. I don't know if you have seen that or not, but yeah, we now work in Rust. And there is not going to be any more rewrites, at least not until it's going to be rewritten in itself. Compiler here. So we do an arc instead. All right, let's see. X into X. So this is a function which is not inferred types, right? Yeah. Since I'm showing the type, maybe I shouldn't even like function this. You know, wait, or is it in a value like this function function type? Like, since the function type is going to be shown anyway, maybe we just do this. You know, because we don't show the body, we don't show like anything here. The type of the function is going to be shown anyway, right? Okay, so x into x is a function which is not inferred into not inferred. In order for this to be inferred, we need to have some type description. So let's see, if I have int32 is an int32, right? I need this to be in scope. So if I say x is int32, which returns x, then it says assertion failed, left is right in the compiler 343. Compiler 343. Okay, so when I have the, yes, okay, I understand now. So what I did is, this is the pattern of the arguments of a function, right? And I did the parenthesis here, which is the scope stuff, and this only works for expressions. So I need this to work on the so I need this to work with the patterns too. So I'm going to match the type that I'm trying to compile into. If it is an expression, then we are going to do all of that stuff, right? Okay, and if it's a pattern, it's not very different. If it's a pattern, it's not much different. We just say that we compile pattern. We compile pattern. But for the pattern, we don't need it to be scoped technically, right? We just say that we compile literally the compile pattern. We just compile the inner pattern, and that's literally the same thing. Okay. Then also there's the type ascribe. Maybe type ascribe also only works with. No, type ascribe works with anything. Okay. So that's fine. Let's see now. Once again, if int32 is int32, and then I say x is int32 into x. So this now is a function that takes an int32 and returns not inferred. So the reason this is not inferred is because I forgot to like have the type information in place. Let's see. So it is when I initialize the expression over here. If this is a function, so this type this type of a function needs to be what? Needs to be what? It's probably like actually when I compile a function, so it's inside the compiler function definition, like over here, right? When I'm compiling things, I know what the result type is, right? I know what the result type is. I know what the arguments are, right? I compile the body knowing what the arguments are, and all I need to do is I need to say that this expression, the body, evaluates to the result, right? So body.data type should be same as the result type, I guess. And that's it. Maybe. X int into X. So now we know that this is a function. So this has been inferred now. Int into int. Nice. Have I ever programmed a game in Rust? Yes. We have a game that's working, that's going to be released hopefully soon. Wait, you are the person who asked me about the other games and like the things that you were talking about, how our art is not very nice or something on my itch page. All of this is done in Rust. All of these things is in Rust. Every single one. I don't have any games that's not in Rust here. I made games in other languages, but they are not on itch. Okay, so we have this function is working, right? So what if I bind this to a value, right? So this is a function. Function f is a function, right? So what if I try to say function f 1, 2, 3? This should return the f itself, right? But this is now wait, hold on. Expected f args, but got f arg. In built-in macro call, the field arg was not expected. Args versus arg. Oh, I see. It's because I broke the call. Okay. Args. Yeah. We rename args into arg. Anywhere else do I have the args? Let's have it everywhere. Just a single argument. Maybe not in the VS Code. Maybe not in a flake. Over here we can have args, sure. Town. Arg. What about type arguments? What do I mean by type arguments? I don't have type arguments. I have only normal arguments. If something like because we treat because we treat types as values, you can have type arguments just normally, like just like any other argument, because because your values can be types, not only like identity is usually input t into t. This means that it is a templated function. Yes, I know. We don't do the into the templates yet. This is going to be like next, I guess. I mean, maybe I can do it immediately. We'll see. This is basically means that ID is not just input t into t. ID is for all t into t, x t into t, you know, something like that. Do I have the ID example? ID no, ID is yeah, there you go. There you go. This is the definition. We have it in test. So ID is for all t, where t is type. It's a function from t into t, right? Which is just this. You're getting PTSD from seeing this for all. What do you think it should be instead? So I'm calling this for all, but what should it be? As you can see, this is an anonymous. This is a closure, technically, right? We don't even have a name for this function before we bind it to a constant. You think it looks fine? Yeah, I think it looks fine. Like this, I could call it a template, for example, right? That would be similar to C++, you know. So like in C++, you say something like template type name t, right? That's what you do it. So this literally is the same. For every. How would that work for a normal function? What's the different, like, I mean, if your function is polymorphic, if the function is polymorphic, it means that it's a template or a generic, like whatever you call it in your language. I'm calling these templates. I define the templates with for all syntax. You know, that's what it is. For all, is how you define a template. I don't think template is better as a name here. Like, or do you think it would be nice if I call this generic? Usually in your programming language there is no keyword for that, right? You just have a I mean in C++ there is, but in something like Rust we just have function with like triangle brackets t, right? So yeah, but like, because this is not necessarily a function, right? I can have generic types, I can have generic anything. So like so this is how you define a generic, and what a generic is, if it's a function or if it's a type or if it's a something else, depends on the body of the generic. Generic template is way better. I don't know. Is it? Is it just because for all is like what? Why do you hate this keyword? This is easier to type than generic or template. Template is pretty long. But yeah, we can consider something else here. I don't know. I don't hate the for all though. I think you would get rid of it completely. Well, but then it would look like this, right? I mean, technically we can make it like that, but then I need to differentiate between, like, I need to have a different syntax basically, right? I'm using square brackets here, for example, right? So I need but we also want to have like arrays easily typable, which probably also want to use like this is a syntax issue, which I don't know. You've only seen the for all in math, that's why it makes sense to you. I don't know. I mean, there is a for in like in Rust you can have a for, actually. In Rust you can have this thing. You can have for t. I mean, it only works for lifetimes, but in Rust you can have for lifetime function. You know, something. So in Rust for all is just typed as for, technically. You use this in trade bounds usually. I don't know. I might I'll consider changing this syntax. But this is good enough for now, I guess. I just don't like the triangle brackets, to be honest. The less than and more than, I don't like that at all. So other alternatives would be... I mean, hold on. How do they do this in D language? In D language templates. Where's the learn? Community. Blog. No. Resources. Tour. Read in your language. No, not reading my language. Where's the next? This is the tour. Features. Templates. Templates page. Let's see how they do it. So yeah, in D language they also say it's a template. I don't know. Maybe we can just have a template. So in D language you initialize them not with like the not with square brackets. You do exclamation mark and then the normal brackets to instantiate a template. It's another syntax that we could use. I don't know. We'll see. For a function at into t. Yeah. What was I working on? Let's see what doesn't work right now. Int is native int. App is x int into x. Here's the function. If I try to call it, function is... Oh wait, hold on. Function is not a function. Okay, I know why. I know why. So this is when I in the interpreter is not a function over here. So like I can only call the I can only call the native functions right now, right? But let's say that I can call the normal functions now. So if I try to call a normal function, then what I need to do is I need to evaluate the function body, function compiled body, right? I need to evaluate function compiled body, and that is my result. But before we evaluate the compiled body, we need to pattern match the arguments, you know. And also function has some captured environment, so we need to, instead of using our current scope, we need to use a different scope. So self interpreter current scope is going to be it's going to be replaced. That previous scope, I guess, is something something. I need to like handle this differently, probably with some immutability actually. So I'm going to replace. I'm going to replace the interpreter scope with function. Oh, I mean, I need to construct a new scope, right? Where the parent is the captured environment, right? New scope. New scope is scope new. New scope parent is function captured scope, and then I need to like pattern match the arguments. So function compiled arguments pattern match against the actual arguments that we passed into the function, right? No, that cannot even fail. All right, sure. So this is the matches, right? So the new scope locals I need to lock these things, I guess, and I need to extend with these matches, right? By wrapping in some, yeah. The match returns the list of bindings and values. Let's see. Let me see where I'm using this. That's not showing me these things correctly. This method call chain might not have the expected type mismatch. Yeah. Match. Oh, it's literally over here, like right above. Right above. So it's the same kind of. Let's just copy paste this for now. So I'm pattern matching the arguments, and all the new bindings I'm inserting into the current scope. My previous scope is going to be saved. I am evaluating the body. I get the value, and I return this value in the end. But I will bring back my scope to be previous scope. There we go. Are we async yet? Not yet, not yet. But we do have functions, I think. Let's see. Let int is native int 32. Function f is x int into x. So this is the function. Function 123 returns 123. All right. So this works. Also, like we can say just that f is x into x, so this is like not inferred into not inferred. But if I try to call this function with something which is an inferred type, for example hello, right, then like this will return hello, and since I have called this function with a string, the function has been inferred to be a string into string now. So these things work, right? The reason we want to go async is because this, what I have right now, only works for non-recursive functions. Because in order to compile something that refers to something that doesn't exist yet, we need to like the compilation can only finish when something in the future has been defined, you know. So that's why we're going to change the entire thing into being async, you know. But generally functions work, right? Functions work basically. I can even like do the generics maybe immediately, because they are basically the same. Immediately here. Let's try to see if I broke some tests or not. Cargo test. See, everything works. Functions. Okay, so simple functions work. So what's the problem, right? So the problem is that if I try to go into and make a mutually recursive functions, Como is giving out 3 points. Nice. Yeah, I saw that. So if I have a function which is like, I mean, let's just call this recursively infinitely. So this is a function that calls like function g with the x, right? And then function g is a function that calls f, you know. So this is not going to work because g has not been found. We don't know what g is when compiling this, right? But we still want the recursive functions to work. So so for that reason, we are going to go async now. Or do we go for templates first? Which one should we do first? I don't know. Async. So yeah, async basically means that everything is going to become async. It's mostly because if we look at the compiling of this function here, right? So this is where I am constructing the compiled function, right? I'm constructing the compiled function, which is arguments and the body. I need to go to definition to use telescope, I think. Can I do this? Hold on. Telescope, LSP definitions. Yeah. This is what I want. Telescope, LSP definitions. Yeah. Hold on, let me just really quickly change my NeoVim configuration. GD. Go to definition. Is there like telescope LSP there is no LSP declaration. What is it? What is the declaration anyway? I guess it's like about the C language. I think I never use this. Go to definition instead of using Vim LSP buff definition is going to be bound to telescope. I mean, something similar to this, I guess. So go to reference is already working through the telescope. I just need to go to the definition through the telescope. Instead of doing this, LSP definitions. And over here, type definition. Jumps to the definition of the type under the cursor on list LSP type definition. I think like I don't even need to have on list, replacing the default handler for non-empty results, because I think LSP type definition would also like just go directly to the definition if there's only one of them there. In Helix with Rust declaration just goes to definition. Yeah, it depends on the language. Some languages just don't have the declaration, I guess. In Guxor, hello. It's going well. How is it going for you? What are you doing? There is also go to implementation, right? Which also I never use. Right. LSP definitions, right? Yeah. Okay, there you go. Use telescope to go to definitions. And NeoVim. You need that watermark. Just unbuy your Linux. Then you will have the same watermark as I have. Is there anything keeping me from using Helix? Since I'm trying to make NeoVim exactly like Helix. Yeah, there is a there's a couple things. I'm using the NVim tree for over here on the left. There is no such thing for Helix. I'm not using it a lot. Like I can go. I'm using this telescope to go to the files too, right? I like seeing my tree though. You know, I like seeing my tree. Also, if you try to use search in Helix, then it will not show you the previews. Maybe you can configure it. Can you? Because if I try to search for like something like to do, right, I can have this preview, and in Helix, you just type the thing that I mean, my Helix does not do that. Let me show you here. If I go to the projects cast, right, and if I go to Helix, if I do slash space slash for global search, and then I need to type something over here in the bottom left, only after I have typed this, only then it will show me the previews, you know? you're using master. So like so I need to like use the master for this feature for the live preview as I'm typing this search. Just like small things like that. What else? I mean, in NeoVim, I don't have the multi-cursors though, which are nice to have in Helix. What else? The context. I'm not sure if you can configure your Helix to show the context of the tree seeder, right? I want to know that I'm over here. I'm inside the function, so I want to see this. So you see how some lines are skipped over here at the top? This is through the NeoVim tree seeder context plugin. There are some other things maybe that I don't even remember. There is the hop plugin. I know that in the Helix you can hop words, right, like this. So you do GW, I think, right, and then you can go wherever you want, which is very similar to the hop plugin in Vim. But you can only do it for words. In NeoVim it is much more flexible. You can hop to like I like the big character where you type the first two character of the thing that you want to go to. So for example, I want to go to the value, right? So I would type the VA here, and then it will highlight all the VAs on the screen, and then I only need to like think I need to think much less. Basically, there's less noise on the screen. I don't use the hop too much though, so maybe not really necessary. What else? NeoVim. There is like the terminal, the integrated terminal in the NeoVim. I like that. Instead of doing Control-Z on the Helix or like using the other terminal, I could use the window manager instead and have a terminal in another window. I think it's kind of annoying. I like this inside the editor directly. What else? Well, I guess the other things are... I guess that's all. I think at some point Helix is going to be better. Also, I use the Neovite for the animations, so it's really nice to have the animations. I like them, you know? I cannot do that in Helix. Helix only works in the terminal. If they add the front end like the Neovite at some point. You can use grep with slash. Yes, I know. But at least for me, it doesn't show me the preview as I'm typing. Like, I need to type the thing that I'm searching for in Helix and then press enter, and then it will show me all the things that it has found. Maybe I have not configured it, or maybe it's the feature of the master branch. One problem with Helix you had is that there is no easy way to navigate the directory of current buffer instead of current working directory, but there is an unbound key for that called file picker in current buffer directory. Wait, file picker in current buffer directory? So like in the same directory as the current buffer? I don't think I ever used that. But you can bind it, yeah. Why would you use that? Just wait, what did I just do? I just did the go to definition through the telescope, right? So it should work now. Should work now. Compiled function over here. So if I do go to definition, once Rust Analyzer is thinking, then I do this through the telescope. Nice. Okay. I also need to do some other things. Like for example, for renaming, I need to, like, you know how when I rename, I need to actually rename in the bottom left. So I need to move my eyes from the actual thing that I'm renaming into the bottom left. Is there a plugin that allows me to like do the renaming in place with a pop-up like in VS Code? I should do that too. Same as in Helix, but I'm pretty sure there's a plugin for the NeoVim to do that better. Anyway, so we were compiling functions and we want to go async because Because over here, let's see, I'm compiling the body, right? And while I'm compiling the body, what can happen is that I can see an identifier that is actually I can see an identifier. This is a pattern. This over here, an expression identifier. So the identifier might be something that is actually declared in the future. So I need to wait for it. So yeah. Is your biggest issue with Helix is just so annoying on larger names that you can use normal Helix keybinds? On larger names that you cannot use normal Helix keybinds? Wait, what? On larger names, you cannot use normal Helix keybinds? Wait, why? Oh, like go... like navigate the thing while you are renaming it, because like in insert mode you want to like do control left control right to like go to the beginning to end. Is there like no bindings for the insert mode? Yeah, you are stuck in the insert mode, but there are like there should be bindings for the insert mode to like do the words. Пошарить свой new vim config. У нас dot files over here. It's done through Nix. Specifically, you want to look at home. No, it's not at home. It's NixOS, NeoVim over here. This is all the plugins that I have installed, and the Lua file is just in one file over here. This is all my configuration. Just 500 lines of Lua. It has those bindings, but they are different than everywhere else, and you cannot change them. Oh. All right. So here we go. We're going to start polluting everything with async now. Most specifically, interpreter get name. So like whenever I want to get a variable and know what it is, since this can be declared in the future, this must be async. Which means that this, I mean, let's start with the scope, I guess. So scope is scope get is async, because scope is something that is like very pretty much on its own. So yeah, this is going to be async get. So what do we do here, right? The scope can be like already finished, or it is not already finished, you know? That kind of thing. It has those bindings, they are just different than everywhere else. Have you tried the key editor? It's interesting. Not ready? No, I did not. Have you tried Cocoon? I have not tried that either. Key editor. First class syntax node interaction, multiple cursors. Is that a new thing? Interactive tutorial in the browser? No, it's just images. For a second I thought... Oh wait, hold on. It would be really nice if you could just like do this in browser. Since this is done in Rust, you could compile it to the web, right? Easily. Anyway. There's a lot of editors. There's also Z editor. What do you think about that? Recursion in async requires boxing. A recursive async function must introduce indirection. Wait, hold on. Hold on a second. Can we do explain? Rust C explain. How do you do explain? Never do this. Explain. That one, right? An async function used without boxing. So I need to do pin box manually. I cannot no longer mark my function as async, right? Okay, I mean sure. Fine. We do pin box future output is option value. A little bit more verbose, I would say. How about we how about we use the futures crate then? Let's see, cargo add futures. Let me move this to the workspace dependencies. Then save futures workspace is true. So I will do something like see, use futures prelude. This thing specifically, so that it's shorter to write, box future box future of option value. Import box future. Okay, I need to import this. This is not in the prelude. Use futures box. Sure. Consider future box future. PI is built around syntax-aware navigation, which is something not uncommon to have, but usually annoying to use. So it's like the tree-sitter selection like I do here, which I really like, but for navigation too. I'm wondering how this works. But I'm too lazy to try it right now anyway. So probably not going to try. But I think like even I can go to like the previous something, right? Like don't you do the same in the maybe like previous, jump to previous previous method start? Like I can jump between methods kind of. It also like jumps between the structs, I guess. It looks like I never use this. Kinda nice, I guess. I'm mostly about this searching usually, I think. Or go to definition. Micro is the most underrated editor. It's modeless, has LSP, has terminal, has multiple cursors, and has a plugin system. Kuvi, hello. Keezy, hello. Okay, so over here we just say async move dot boxed local, no, dot boxed. There you go. The expression has type. Wait, because this is no longer async since I'm returning the future anyway, right? We do this. Lifetime may not live long enough. Lifetime may not live long enough. Method was supposed to return data. Yeah, because box future needs to return the thing with this lifetime. Yo, Adam, thank you for the raid. Hello. Hello guys. How are you doing? Yeah, thank you for the raid. I'm not working on a game today. I'm making my programming language. But Are you guys excited for the Ludum Dare that's to come? I'm assuming Adam... Is Adam... has Adam been participating in all the Ludum Dares? Or not? I don't know. Maybe he's not doing game jams anymore? I don't remember. What was the last game jam from Adam that I saw? I remember I remember the Ludwig jam. But yeah, I am making a programming language. In Rust. And right now I am working to support mutually recursive functions, which means that I'm converting all my code into async code because when I get a name, the game might be declared in the future, so I need to wait for it to be declared, kind of thing. He had a great looking game for LD. Yeah, I mean the Adam's art is very nice. What's his Adam? We probably can just Google. Itch. Upon Hill itch.io. Yeah, the art is very nice always. Does some tutorials too. I don't think I played this one. Is this not even for a game jam? 5 months ago? Is 5 months ago the LD? What was the last LD's theme? LD55, yes, it is. What was the theme of the last LD? Did I participate in it? Oh, it was the summoning. Yeah, right? Yeah. We did the summoning game. This one. The GTA Online. Where you drive around. Mm -hmm. But I think I have thrown all of my ammo. I did not read through the instructions. Alright, anyway. This demon is huge. It's too fat to even move and eat me. Would I read instructions? I mean, yeah. Not really good with reading. Alright, anyway. Nice. The next Ludum Dare is in 4 days, or is it 3 days already? 3 days and 13 hours. The theme voting is here. Let's see what the themes are. Break the cycle. Reflection, isolation, under pressure, orbiting, transportation, connections, mistakes are permanent, recycle, pathways, folklore, downvote. Ruins, one too many uses, mutation, tiny creatures, shelter, echo, ritual, alchemy, echo. Wait, what was the themes of the previous Ludum Dares? Can I have them on the screen? Because I think something like this cycle. There was stuck in a loop theme not so long ago. Connections, I feel like this one has been somewhere, or is it maybe in the GMTK 2023 or something? It was like connected, the theme, something like that. Why do you hate folklore? Break the cycle is nice because it can be taken literally. I mean, yeah, but it's like similar to the previous themes. But I mean, I guess I don't really hate the theme, but I don't know. Folklore can be good for any kind of game, no. But it's too, I don't know. I personally I don't like it. It's too broad because like literally it can be made. It can be for any kind of game. You know. Also, it's basically like folklore is stories, right? So and I'm not really into story-based games. I'm more of a gameplay guy. So so yeah. I don't want folklore. What do we want here? Any creatures? Has there been something like this before? I think I would I think I like this one. Not sure. Mutation. Mutation. Not sure. One tool, many uses. I think I've like maybe I just seen it in the previous suggestions. Echo ritual. Which one do you guys like the most here? I think I like tiny creatures the most. Because then I would make something like an MMO where everyone is playing as a tiny dude and we will like, you know, in all of the games that I've made previously that are multiplayer, you couldn't really see like the big picture. But if we make the tiny creatures and there's like thousands of people with a lot of fake ones, obviously, it would be nice. Fishing in reverse using ECS. I will probably use the Evenio, not the Bevy ECS, but Evenio. I like that one. Not the issues. This is kind of similar to Bevy, but it's based on events. We used that in the summoning last time. Wait, what is this GGJ 2016? Does it mean that this theme was used in the Global Game Jam 2016? What is this thing on the screen here? Ritual is Global Game Jam 2016? Not your ECS, SMH? Fishing in reverse? Oh wait, tiny creatures, like it could be about the fishes, indeed, yeah. Anyway, ritual I don't like, alchemy I don't like, echo I don't like. Oh, there's 2 echoes? Wait, is it normal? Hold on, refresh. There's 2 echoes. How does this happen even? What? It's all rigged. Shelter, mutation, one tool, many uses, ruins, pathways. Recycle, mistakes, a permanent transportation, unbidden pressure. I don't know. I don't like anything. Tiny creatures. Tiny creatures. Well, I mean, actually, you know what? I'm going to make everything as 0. The only thing that we actually downvote is the folklore. All right. Let's continue making the language. The lifetime may not live long enough. All right. Why? Box future has a lifetime. Send a. Because boxed. What is happening here? Method was supposed to return data with lifetime number 2, but it's returning data with lifetime number 1. So is it because of the lifetime capturing is a little bit weird here? We need to do this instead. Right? To tie these lifetimes together. Okay, sure. Let's do that. Okay, next, mismatch type. So now when I want to get something in the interpreter, this is going to be async now. Right, option value, so this is .await, right? That's easy. Actually, you know what? So like, let's just take a look at this here. So this is the scope. Like I said, we can get some names that are going to be available in the future. Right now, I'm not literally like awaiting anything, right? But one of the properties of the scope is that is it like still being defined, or is it not, you know? Basically, so let's have somewhere you know, like closed. Is it going to be like a boolean? So we're going to have an arc. I guess not an arc, just an atomic. Wait, hold on, I need to like wait until it's closed too. So if like what should it be? Like I would make it an atomic boolean, right? But then I need to wait until this boolean becomes true. So what is this primitive called? Sync. Like, is it a barrier? A barrier enables multiple threads to synchronize the beginning of some computation, right? Is it a barrier? Which also means that I need to not use std sync. I need to use something async. Async rust async barrier. Async barrier, literally the crate. Is this the one from the small runtime? Yeah, I like these guys. I'm going to use this then. This crate is an async version of the stdsync barrier. Counters to synchronize multiple tasks at the same time, creates a barrier that can block the given number of tasks. No, I think it's not the barrier. Okay, barrier is for other things. What am I trying to look for? Is it a semaphore? Or what? Sync. What do we have here? Convar condition variable. Condition variable represents the ability to block a thread such that it consumes no CPU while waiting for the event to occur. Yeah, so like the convar that we could just like wait for, right? Creates a new condition variable which is ready to be waited on and notified. Yeah, so like is there a thing which is a sync convar? No. Let's take a look at the small cont var, no, maybe async lock, async synchronization primitives in general, barrier, mutex, are log, and semaphore. Just async cont var. Down. Is this an async std? There is there an alternative in Tokyo? Looking for is notify. Okay, so in Tokyo there is a thing that's called notify, mechanism to notify a single task of an event. Can be thought of as a semaphore starting with 0 permits. So we can just use the semaphore for it, right? Async lock. Semaphore. A counter for limiting the number of concurrent operations. Ready to semaphore with the limit of this operations. Try acquire. And then like waits for a permit. Acquire blocking. Acquire arc. Acquire arc blocking. Like I could just hold the permit until the scope is ready to be done. Async notify. Maybe this one? Oh, py. No, not Python. Just async notify. General version of async notify like Tokyo notify, but can work with any async runtime. A little weird. Town. If notified is called before notified await, then the next call to await will complete immediately, consuming the permit. Yeah, this is exactly what I want. Maybe I just if I look at the small, because this just exports everything. Maybe does it export everything? If I search here for the semaphore, yeah, it does. Okay, is there notify? No. Cond. No. Why do they not have that? That's weird. As login IO. How is it implemented in this? Great. Does anyone use anything like that? Or I mean, most of the people use Tokyo, I guess. Can Tokyo run on the web? Rust Tokyo WASM. Can Tokyo runtime be used in the WASM? Tokyo does have some support WASM. See WASM support in the docs. You need to enable the RT feature. The full feature doesn't work, so it causes a compilation failure. However, it does not support multi-threaded runtime, but therefore does not support runtime new. You need to use builder new current thread and enable features you want in the methods. Yeah. I mean, not. I don't know. I think that if at some point I want to compile the interpreter to the like to have a live demo on the website, it would be nice. Um. Async notify. Let me see here again. This is the great. It's very small. It's just what is it built on top of? Maybe there is like futures. Maybe something in the futures. Docs futures. Notify. Like it's more like a channel. No, it's not a channel. Yeah, I don't know. There is an atomic boolean and an event, and an event is coming from the event listener. Okay, what's an event listener? Event listener is the thing from the small runtime, I'm pretty sure. Yeah, it is. So this is a script primitive similar to event counts. You can use this crate to turn non-blocking data structures into async or blocking data structures. A simple mutex implementation that exposes an async and blocking interface to occurring locks. Wait for another thread, sets a boolean flag. Yeah, like kind of this thing is what we want, right? And a synchronization primitive for notifying async tasks and thread event. An event of type T, a synchronization primitive for notifying async tasks and thread. Listeners can be registered using event listen. There is two ways. Listen, is this async? Press new listener. Implementations. It's not a future. Wait. Down. What about the repository? So in the small runtime, it's called an event, right? It's not the exported directly event. No. Rust small event. Event listener. Let's take a look at the repository again. Okay, this is the main thing. Subcrates, async channel, multi-producer, multi-consumer, composable async executors, file system, adapter for I/O, timers, lock, barrier, mutex, read write semaphore. primitives, task abstraction, a lighter fork of futures, polling. What about the async task? Maybe that's what I need. Task abstraction for building executors. Probably not though. So they don't expose the event listener create here. Event. Notify async tasks or threads. Alright, well, let's go back to the source code of the async notify. It's just like a little bit weird. This crate is very small, and no one is using it probably. I mean, there's 6 stars here. 4 years ago. Maybe there's like a better alternative somewhere. This is pretty simple. This does exactly what I wanted to do though. Like Tokyo notify. Runtime independent. We have count, we have atomic bool. Event. Notify. We store count true. Why is count visible boolean? So basically, has it been notified already or not? We self-event notify 1. Notified. We try the self path. See if already there. Otherwise, we create the event listener. So event listener is the wait, hold on. Event listener is the future. All right, hold on. Small. No, event listener. It's like the event is not, but the listener is, right? So we get the listen and we get the listener as a result, right? What about the T? T does not need to do anything. All right. Event listener. In a synchronous manner using await, in a blocking manner using wait. So we just do the future. But it will not work if if we like already have finished, right? So I really what I really want is this. I mean, this looks good to me, even although no one is using this grid. We can add that, whatever. Cargo, add async notify. Okay, so here's what we're going to do in the thing here, right? So since closed, whether we have like finished like building this scope or not, is going to be an async notify notify, right? So when we construct the scope, and then we will have the function that is called like close here, right? Closed is async notify new. So we do self closed dot notify. This does not. At most, one permit may be stored by notify. Many sequential calls to notify will result in a single permit being stored. Yeah, I mean, that all makes sense. We just notify this thing, and then what I say is that so here it is, right? If So like we either know the name already because it's already in the locals, like because it has been defined before, right? Wait, hold on. Let me actually think a little bit. If we have something like let's say function f, uh hold on, we have an example already, right? Examples, recursive closures over here. Let's take a look at this. So we have the function f, which is calling the function g. We have the function g, which is calling the function f. It only goes a certain depth in here, right? But yeah, can I disable the these underscores? Is this the spell checker? Spell checking? No spell. Set no spell. I think it's the spell checking. Yeah. Okay. So the thing here is that we have the print here, for example, right? And print is something that is like defined not inside this recursive scope. So like if I try to like do the await for every single thing, isn't it going to wait too much? You know? I mean, not all of the scopes needs to be recursive. We need to have specifically recursive scopes sometimes. So some scopes need to be not recursive. You would get into a deadlock. Yeah. But I think like so like the way it works in the OCaml version is that when I try to call the function, or when I like basically there like instead of doing the async compilation, we were compiling them, like I guess just in time is what you can call it. Like when you call a function, so like the function would only store its like original AST and captured environment, but I would actually compile the function when I try to call it, you know. And that would then like know about all the things. But I think that's not very good, and I want, like, there were some problems with that. Specifically, they were like, because I'm not compiling them, if I never call them, it means that they're never type check. So I want them to be compiled as soon as everything that we need to know about them is there. You know, kind of. So I think there should be like a mix, right? So I need to sometimes be able to tell the function that it must be ready now, right? And if it's not ready now, and I was waiting for something to be available, then it means that um it would just label it as dead code elimination. And then I'm going to take a bathroom break. Oops. I mean, one of the things that I could do is like, you know, I like whenever defining something recursive, I should not like call something from inside this block. Like, for example, I should not be able to call this function from inside this recursive block, you know? Right? So if I actually try to use this, I mean, but for some things, I think it would make sense. I can try to just like implementing this thing. So I had this rough idea about the async compilation, but I'm not sure how it's actually supposed to work. But yeah, let's see here. So if something is already known, also the scope is recursive or not. Let's have this recursive is a boolean, you know. So recursive is recursive, you know. Let's have this as an argument here, recursive boolean, or I don't know, let's have new, which is going to be recursive false, and then let's have function recursive, which is going to be the same. Something like that. So if both times false, true. If I am recursive, then I would loop here. Well, I guess I just do a loop here. I guess I just do a loop. I'm going to try to get it in a loop. If I am not recursive, then I'm going to break the loop. Otherwise, I'm going to self-closed, not notify. Wait, what's the API there again? Notify. Notified. Wait for notification. Yeah, there we go. So notified. Await. Right? This just doesn't return anything. We just wait for being notified. And I cannot know if it's like already closed or not, I guess. Closed notify. Closed atomic boolean, then closed atomic boolean. False. Self closed set no dot mm, mm. What is this all auto completion that I don't care about? I just store. Something something. Bum, ba-dum. If self closed. I just read this in the beginning. That was closed is self closed load. Just if was closed, then also break. Otherwise, we wait for the notification here. There you go. Good enough, I guess. Although, I mean, technically, we can maybe wait for like not the entire recursive thing to be defined. I just have a to do here. To do maybe wait for the name, not entire scope, question mark, something like that. Okay, otherwise we search in the parent. Let's have this scope in its own module. This is public. This is public. This is public. This is public. Atomic boolean. All right. Now let's see here. So now everything becomes async, including the evaluation, right? So eval is going to be async here. And this is recursive. So we will need... oh, and this is a closure, because I'm trying to see the thing. Okay. Async, sure. Which means that when I call this closure, and then I need to wait it here first. Sure. Wait, does it mean that it's recursive? Like, it's not calling into itself. It's going through a different closure. Is that the indirection? That's enough? Consider awaiting the future and calling in a method on its output. So over here, when I have a binding, in order to evaluate what the binding evaluates to, we need to Um, I mean, over here, I think we don't need to await, but we do. This should not be async. Question mark. Wait this. Wait that. Wait this. Wait that. Await everything. When I compile, yeah, like when I compile, this is the thing that must be await for sure. Await is only allowed inside async, so my compilation is now an async process, right? Which means that compilable, we have an async trait here. This method is async, so it expects a future to be returned. Over here, I guess the pattern compilation is also async. Async traits. Yeah, we have async traits in the Rust since recently. Relatively recently. When was it stabilized? I don't know. I didn't use it yet. This is the first time. I was using the async trait macro before. Great. What is kast? I'm making a programming language, Solburn. Hello. How are you doing? Kast is my programming language name. So kast compile is async. Qv++. Async. Await. Await. Oh, this means that all the macros are also async technically. Let's see if we can do this here. So here's my macro, right? This is a function that must be async, which probably will return like the box future then. Box future, this, that, right? Which means that this is okay. Let's see here is 4a, 4a, a mut kast. Hold on. Wait a second. We have a mutable reference to self too. How should this work again? Kovarik says he wants to make K++, which is C++, but sane. Has he seen Rust though? Because I think Rust is exactly C++, but sane. Also, has he looked at other languages that are C++ but sane? Has he seen the C++, the safe C++? There's a proposal for safe C++. Although I'm not sure if that would count as sane, because it makes the language to like have both the old and the safe version at the same time, which is probably insane. He didn't gel with Rust. What does gelling with a language mean? Or do you mean he didn't like Rust? Or he didn't try it? So what's the thing here? This future needs to Can I do this? I'm not sure if I can do this. Maybe I can. I also maybe will like get rid of these lifetimes at all, and like just copy and use immutable stuff instead. We'll see. This might work though. So this means that all the functions, all the macros are going to be. Can I just make this async, and then this is supposed to be like the same stuff as this definition that I had? Compile into await. Async. Await. Oh, Veldak. Veldak was
Hello
summoned by
there.
the Kovarex. Mentioned in chat or something. Something related to Factoria mentioned, and Veldak is here. Immediately. And now I can no longer transpose, so this is more like an in future now. So, okay. Sometimes Rust is annoying because I need to, I don't know. Because the features, they don't compose well together. So I'm going to just do a normal match here. Match B, if it is some B, then self-compile B, wait question mark. If it's none, then it's none. This is some. Like that. Okay. I can do this, but I cannot do this with a map. Just so you know, Beldak is a nice person IRL too. Cool. You're in office. Everyone went to lunch. I put headset on to listen to something, and you see me online. Nice. Also, watching coding streams might be acceptable when you are in the office. Did you put me on the big screen in front of all the all the colleagues? Async. Await. Await. Wait, what was the key? The method M? Okay. Async. Wait, what? That was, that jumped a little bit too far, I think. Await. Wait. Wait. Call. Async. Wait. Wait. Non-primitive cast. So let's see what we have here. We have a non-primitive cast. We have 4AB. Okay, so we actually have a 4AB. So so the actual function is having like 2 lifetimes AB, where this is that, yes. Into the so but what was the future? Impl future. Like, what is the lifetime of this impl future, of this function actually? That's the question, right? What's the lifetimes of this async function? Because so we have 2 lifetimes here, right? The lifetime of mut self and the lifetime of this thing. Does errors look like C++ template errors? Not good. I think, first of all, there's like 10 errors which are the same, right? And this is not like C++ template errors. This is much simpler than that. This is like it's because every single one of these is generating the same error here, so I'm seeing all of them. The error is just like 3 lines long. It's not that bad. It's much better than C++. It just doesn't show me the lifetime of the future is the problem. Made a photo of your setup in the office with Groovy on big screen. Nice. Davey says, ooh. Davey. Is Davey here in chat? Ew. Hello, Davey. How are you doing? I was going to say something about the link cider. Like I think that we want to make progress, but I think that where is it? I don't know where is it, but the level selection for the things, I think we should do it differently. I think we should use the existing level selection for the global level selection. You know what I mean? How's the baby going? Baby is going fine. It's not going yet. It's mostly just lying, you know, and crying. Not really going, you know. Let's see. For AB, can I have these lifetimes here? For AB. Let's see. Non-primitive cast 4A into this into pin box. Oh wait, hold on. Yeah, hold on. Okay, I understand actually what happens. Yeah, because like, yeah, this makes sense. It's because like I say that the built-in macro returns the boxed future, but I'm actually not boxing the futures, right? So that's what I need to do. I need to box them. So let's see. This means that I cannot do this as async functions actually, or at least like maybe you know what? Maybe we can do like this. Maybe we can do this. Maybe I can do like this function to be boxed, because like every single function here has its own type of the future, right? And we want to box it. And they take cast values and span, and then we return async move this. I guess we just do cast dot name values span weight, which means that I can just do this and then just say boxed. I don't even need to async move anything here, right? Can we do that? Type annotations needed, cannot infer the type because this is a mutable cast. Mismatched types, expected closure, but found a closure. Literally at the same place. No two closures, even if identical, have the same type. Consider boxing your closure. Yes, of course, because I need to box this closure. So built-in macro, yeah, because like this is no. I guess we need to do this. Like this is the closure, right? Shit. This is the closure. let closure be this, right? But I will say closure as built-in macro, right? That's what I want. Provide the name of the argument. Argument number 3 of type span is missing. Values span. Wait, what? No, it's not. Oh, it's because the compiled type is expected there. Yeah, I forgot the CTY here, right? CTY is another argument. Okay, nice. No more errors, easy. So we call this function, we await it, right? Await is only allowed inside async. So the macro over here is also async. Call the macro. Oh wait, hold on. Macro of this name is impl function into okay, let's see here, box future of that, right? Now I need to have the lifetime impl fn. Okay, impl. Where's the 4a written here? 4a fn a a a, right? That's how we do it. This is not async. So over here we say move, and we say async move, and we say boxed, and we await there. Yeah, there we go. Compiles. How about this interpreter scope? Yeah, interpreter scope is in different place. We just use scope, right? Lifetime may not live long enough. Return this value requires that number 1 outlives static. It's because the macro name, right? Where's the name used? Oh, it's in formatting. Okay. Yeah. Macro name. Where is this being used? Macro, built-in macro name. Definition name, strip prefix. Just clone it here. Macro name is macro name 2 owned. Sure. We capture this outer variable. Clone the value before moving it into the closure. Macro name is a string, is moved, yes. Why would I need to clone it? Town. Captured outer variable. Cannot move out of macro name. Oh, because this function needs to be able to be called multiple times. So I need to in fact clone it over here inside this thing. Okay. Next, this macro. We're going to await that. No, not await that. We're going to await that. Then over here, we're going to await that. And then over here, the field locals is private. Autocomplete. Let's just have self I mean, yeah, this is private. That makes sense. Because I might change this from a mutex to something else later. You have written your first C# Azure function. It works on your Mac locally. It doesn't work after deploying to Azure. Let's just make this public, whatever. Enter scope parent. I'll make this public. Whatever. Okay. Compile AST await. Evaluate expression await. Eval AST is async. A recursion in async requires boxing. Okay, it does. Okay, let's go ahead and box this thing. This is going to return the local not local box future of this thing. Evaluate a box future await yeah, so we need over here. I think I can just do over here async move, you know, that body is that impl is async move. So we do something like impl await, we do this, and then we do boxed, right? Mismatch types eval AST await. This is async. Evaluate source. Sure. I mean, at some point we need to stop being async, right? The question is where. Wait. A method wrap error. There's a method map error eval. Wait. Type ascribe. All right, nice. The lifetime might not live long enough. Returning this value requires that number 1 outlives number 2. Let's call the lifetime of this reference number 1. Turn type of closure. That. Mismatch types, expected pointer, found pointer. Cargo check. No method named into named opt. No method into unnamed. I don't even have these lifetime issues. This is the thing that doesn't exist, or what? Compiler 324. Values. Wait, into write everything. Method into named opt for tuple in the current scope. Wait, what? It literally exists over here. This should work for every t. No method into unnamed. Ah? This error makes no sense to me. No method into named. Oh, there is a method into named with a similar name. Wait, no, hold on. There is a method into named with a similar name but with different arguments. But into named opt is also a thing. There we go. Yeah, it exists. It is literally here. No method named into named opt is found for struct tuple. Can anyone explain to me this error? This method literally exists over here. I can go to the definition using the last Rust language server. Let's do something like cargo clean and then check. Is this a bug or a feature? I guess it was a bug because after cleaning it all works. And we have the actual error. So the actual error says that the lifetime might not live long enough. The return type of exposure is let's call the lifetime of this reference 1. So the kast, this one is lifetime A, right? This type is more general than the than the than the expected pointer type this. So yeah, there you go. So like it's this lifetime here. That is this lifetime here. Wait, I can like go around this by like cloning shit, but what is the actual problem here? What is the actual signature? If I'm defining an async function, I'm defining an async function which takes two references, a reference to like this reference and this reference, right? And I want to convert. Let's go to the playground. If I say async function foo, we have a which is this, and b is this, right? Do we have futures here? I think we do. Function main. Let's see. Let f is let's see. So I want to have a function pointer, right, from 32 and I32 into a box future with output being nothing, right? And I want this to be full as that, right? Because this is a function. So what should the lifetimes be here? Use futures future box future full. Well, I mean, this I cannot do because this is a concrete, like this anonymous future I cannot even name, right? I guess what we actually want is we want to like try to write this without the async. So function foo boxed foo, let's say first unboxed, right? A I32 and B I32. So this returns impl future. Output is nothing, right? This would be just foo AB await. Does this work? Cannot find trait future. Use std future. The await is only allowed in temporary. So we just do this, right? Hidden type captures the okay, the hidden type captures the lifetime that does not appear in bounds, right? So we need to do a lifetime A, right? That's what I did, literally. Plus A. Like it's before the boxing even here, right? A. Okay, so this works, but what happens if this is mutable? Then it says mismatched types, right? Because I mean it does mismatch. If I make this mutable here, this still compiles technically. So So this is technically for AB, right? These are independent lifetimes, kind of, but over here I say that they are like the same, and it still works. Okay, sure. Let's try full boxed. So full boxed would be a thing that takes a I32 and B I32, and this instead of impl we return the box future. We return the box future a nothing, right? This would be foo ab dot boxed, and that should still work. But they say no method boxed because I need to do use futures prelude, I guess. This does compile. So what is the problem then? The problem is that I go through a different like closure then. So if I say over here, if I say what, like move A B um what did I write? Return time of disclosure. Reference A. What if happens if I do that? Still is the same, right? It doesn't matter. Also, this is box, so like, what I want is I want to have a function pointer to something that returns a future, right? Okay, hold on. Let's see. So yeah, so what I want, type function pointer. This function pointer that I want is a function which takes mutable I32 and reference to I32 and returns the box future, right? Nothing. So I want to convert this into that somehow, right? Because this is a function, right? Function ptr, which should return function pointer, right? So can I just do foo as underscore? This will not work because I need to have the lifetime specifiers here, right? So I need to have the for a here, a, right? Does this work? So this says non-primitive kast. Wait, hold on. Yeah, this is a different because it's not a boxed yet, right? So I want specifically to have the full boxed here, right? And then we have the mismatch types. Expected pin box found closure. In the full boxed. Wait, hold on a second. Hold on a second. If I do this, then the code compiles? Oh wait, the code does not compile anymore. Wait, I thought this... Wait, hold on. I thought the code was compiling. Foo boxed. This is just foo AB boxed, right? That's what was compiling. Yeah, there we go. There we go. This. Okay, this works. So I can have this into a pointer. All right. And then what we do is instead of this function, we were doing the closure, right? Immediately, right? That's what I'm doing here. I'm doing the same thing, but through a closure instead of through a function. So because it's a closure and I cannot specify the I cannot have the lifetime annotations on the closure. I think that's the issue. So like if I say a foo pointer with closure, right? This should return function pointer. So instead, I want to inline this function over here, right? And just use this async directly. So what we would do is I would say a and b, and then foo ab dot boxed, right? Like this. This compiles. This compiles. This compiles. What if I specify over here the types? Mute i32. It still compiles. What's the difference then? What is the difference? Let's try doing this without the macro first. Let's try doing this without the macro first. I will say that built-in macros dot insert. Let's just have one of them. Let underscore built-in macro is closure, right? Closure kast cty values and span. And then we do kast let's say macro native, right? With all of these arguments. So we want this to be boxed, right? This looks like it does compile. So what is the difference then when I'm going through the macro? Is the difference that I have specified the mute cast here for some reason? Doesn't, wait. It doesn't look like that. Is it because I have constructed the closure into a variable and then tried to cast it? C, let C be that, and then I cast it. Yeah, there you go. Look at this. This is bad. Lifetime might not live long enough, so like you need to like assign it to something with a known type immediately. Otherwise the type, otherwise it's annoying. You cannot like have the for thing to annotate the closure with correct lifetimes immediately, right? Is there a proposal for that? Rust closure explicit for syntax Rust closure lifetime annotation. Is there a proposal for that? How do I declare a higher ranked lifetime for a closure argument? You can use function to apply extra constraints to functions and return types. Like, I'm just wondering if there is a closure lifetime binder, the RFC summary. Allow explicitly specifying the lifetimes on closure by the 4a. This will always result in a higher ranked closure, which can accept any lifetime. Closures defined without the 4a syntax retain their current behavior. Lifetimes will be inferred as either some local region or higher ranked lifetime. So this RFC has this been accepted or not? This is from 2022. This is merged. Because it has been accepted, right? Or is it, I mean, merged means accepted, right? And if it is accepted, then there must be a tracking issue, right? Rust issue. Tracking issue for this. So if there's a feature, does it work in nightly? I'd like to work on implementing this. And there's a tracking issue for the record if you have a bug. So there is something. Closure is internally loaded environment in regards to the lifetime of the arguments, and you need strong hints in order to make a closure such similar to a normal function. Let me just subscribe to this to see if it's going to be merged. This is one of the things. Okay, so I figured out the issue. right? I think I will like get rid of the lifetimes anyway. It's just like I need to like I don't need to do this as built-in macro. I need to have this lifetime this annotation immediately built-in macro, so that we know what the types, what the lifetimes should be. Otherwise the inference doesn't work really well, right? So we don't have this issue anymore. The other issue is this over here. We evaluate the source in the REPL. The evaluating of the source should be here. This over here should not, like, this is not async anymore, right? When I'm in the REPL, I need to I think eval source is the thing that is not supposed to be async, right? So which means that this evaluating the AST should should not even be awaited. We're not supposed to like run any async runtime. We are just going to I need to do something here. Features, I don't know, let's do a block on for now, but it's not really what I need. Not really what I need to do. Because it can actually block. I need to give it an error if I cannot compile something still. Although, wait, hold on. How can something happen? How can it happen that I cannot compile it? I'm not sure. Use of async fn in public traits is discouraged. At auto traits cannot be specified. Yeah, sure. Just run REPL. Okay, let f be x into x, right? F hello. So this still works because it was still compiled because I don't have any recursive scopes right now, right? In order for the recursion to work, I need to introduce the recursive scope. Right. So for that, we need to have like a recursive. F is x into x thing, right? So we need to, I call it struct definition. Sure, let's call it struct definition. Tyler, macro struct def. Struct. It was supposed to work for like the recursive definition is compiling down to a struct. It was my idea. Okay. Std syntax struct. Struct is just something that has a body, right? So struct is always an expression. And we say let a body be values to ref into single named body. Rep macro received correct arguments. Okay, we return okay compiled expression. So we need a recursive expression, right? Expression recursive. I just call it recursive for now. Recursive and body. Body data is span dot init, like that, colon span, and then body. Body is self compile. Body. Await question mark, right? Like this. Expression. We need a recursive expression where we have the body, which is, I guess we are going to box this. Body box new body. Okay. Expression cursive. Is not introducing any new bindings. Sure. Expression recursive. Right. Recursive. Expression. Expression recursive data. Expression recursive data. Okay, and then evaluate and initialize. Okay, so when I initialize the recursive expression, I need to say that we keep the recursive expression. Data is span. A body is going to be kept as is. Data is expression data. Where type is the same as body type. Body data type clone, right? And span is span, like that. And then this is the last thing. So when I evaluate the expression recursive, then technically all I need to do is I need to evaluate the body here, right? That's technically all I need to do. But we need to do this inside this scope, right? So we say self enter scope. Interpreter. Enter scope. Enter recursive scope. Exit scope. Exit scope also needs to say that that the current scope needs to be closed, right? Something like that. Enter recursive scope is same as entering scope, but making it recursive. Scope recursive, sure. Let's have this for now. Recursive data can be ignored. You can alternatively the sugar to the normal fn. So async functions in traits is something that is discouraged, is what they are telling me. You can suppress this lint if you plan to use the trait only in your code or you do not care about the traits. Let's go to the lib. No, not this lib. Let's go to the lib. Let's go here. Allow async fan and trait. Unused import. Scope new. Allow clippy new without default. Okay, there we go. All the warnings are fixed. See if this works. Probably not. Recursive. Let function be function. Hold on. Because like this is a recursive scope, right? So I can refer to itself technically, right? But it says f is not found, even although I am recursive. Right. Wait, but why is that? Hold on. What if I say recursive f? Okay. What if I say recursive? Let f be x into x. F. F is not there. That makes sense. It's inside the recursive block. Let's see. Let f is a recursive. Let f is x into x. F. F. Hello. This works. Okay. GX. G not found. So let's try this here. Let G be native print. How about that? G is not found. Okay. What if I say let G be native print? I also say let F be X into GX. Then it works. So F is string into string. Wait, why is F string into string? That feels incorrect. It has not been overridden. Still is the old F. What about let G? G is a string into string. Because I was returning F. I think I may have like, because I'm doing like, something is wrong here. Let's instead of doing it in a REPL, let's do echo, or I don't know, let's even do like not mutually recursive, but just something that's declared in the future is the first thing that I would do. Call call future call future. Yes, sure. Do this. Let we say something like recursive. F is x into gx, right? G is native print, and then we return F. This is something something. F hello. That's what I want. Just run Apple examples. All future. All right, G not found at line number 216. So over here, the G is not found. If I do this, then F is not found. Wait, what? At line number 4 over here, this F is not found. Now that makes a lot less sense to me. So did I break stuff? Just run REPL. If I say let X be high, X. No, not this, with the semicolon. No, this works. This works. So if I say let X be be, I don't know, y into y x. This is a function, not inferred. Yes, so this works. What's the difference here? Because I'm inside the recursive block. Recursive, let x be high x. This is still working. Okay. What's the difference then? Let f be x into x f. Like this works. What's the difference between this and that? Because I'm calling into a function g, which is obviously not called. But if I say let g is something else, okay, that makes sense. Hello. This say that expected string, so because like I cannot call a string obviously, so the g must be a function. Like this works. Native print. That then f is not found. Why is that? When compiling f. Given enough eyeballs, all bugs are shallow. Linus Torvalds. Go. X into X. F is not found. What language is KS? The language that I am making. It's called kast. Load there. I'm trying to make this compile. It's just not finding the F, even although it has been defined over there immediately. F. Does kast support casting? Yeah, casting is one of the most important operations. Instead of supporting traits directly, we have a more like native feature, which is casting and defining your own custom casting rules. So like, you know how in Rust you do something like you have a as something in Rust. What about I guess I don't have it, but in Rust you can have like type as trait, right? And this is how it's implemented in kast, like as just a casting operation. So you can define how certain values can be casted to certain types. So trait is just like a specific thing that you could cast into, similarly to how you would cast a character to an int, like. Trait is nothing really special. It's just going to be like a template. So yeah, we have casting. Is the short version of it, and we use it to implement other features. It's not in the current version yet, but I guess the older camel version. Yeah, let's see. If I use std, for example, we have the parse trait. Right, parse. I mean, it's not showing what it is. This output is not very useful, but I can say something like int32 as parse, and this is like the definition, right? Parse for integer is a function which takes a string and gives me an int32, right? So that's how we do it. Right? If I said something like int64 as parse. If I did this, I guess I did not, because int64 does not implement the parse, apparently. I don't remember what implemented. Maybe a float implemented this. Maybe float. Yeah, float 64 as parse. Yeah, this works. Okay, right? So this is how we can, for your C brain, it's like casting operator in C++. Um, it's like treating a value as a different type, but that's it. And in this case, the parse is a type which specifies which has a which is basically like a function of how to parse, right? That's what this is, kind of. You know, I don't know what, like, a casting operator in C++ is what, like, in C++ you have not the operators, you have like the functions, the casting functions, right? The dynamic cast, static cast, things like this. In C, casting is basically implicit usually, right? There is no explicit cast operators in C or C++. Anyway, I don't know if that made any sense to you, but basically we have casting is what I mean. And that is a pretty core feature that is required to implement other features such as traits. Um, um, I need to understand why this does not work, right? Why is f not found? Why is f not found? Because I'm trying to... Let's take this and let's remove the recursive, right? If I remove the recursive, let f, like, I just say this. Instead of recursive, I just have this inside the parentheses, right? It will still say that f is not found on line number 5. Okay, so it has nothing to do with recursiveness. What does it have to do with, then? Well, I think I understand what it means. So let's see. So this is the recursive block, right? In order to know what f is, we need to first close this this recursive block, right? I actually expect this to like deadlock right now, because in scope, if I say get name, right, recursive, is false. Hold on. If was closed, then break. Was closed. Closed is false. I store true when I'm closing it. Hold on, what if I don't store true? Am I going to deadlock then? No. So why am I breaking then? Why am I breaking then? Like, am I not recursive? Print was closed. There's no way I'm getting here, right? I'm not. So if I'm not here, then why? Then why? So I have not found the value, right? F not found when compiling token F. Let's do here tracing info. Here's a dead simple of a example of a cast operator is C++. Static operator int. Yeah. And this is defining your casting rules, yeah. Sure. But okay, so I mean, in that sense, it's like very similar. Yes. Operator int though should take an argument, right? From like what you are casting from. Oh, I mean, this is for class foo, I guess. Wait. Operator int. Return some int. Oh, it's like casting foo into int. Okay. Sure. Sure. Something like that. I guess it's similar to that. Maybe. It's different though. Um a little bit. Like what the way we define it, let me see if I can find a standard library maybe. We define this same as we do for traits in Rust. We say implement this for that as this. Actually, you know what? I think I might change the syntax for this. So like type name, you know. So in this case, I define how to cast void into a type name, you know. So I think I could instead write something like implement void as type name to be equal to, you know, type name to be equal to name is void, something like this. So like this is the value that is like the resulting value of what of the casting. This is the type that I'm casting into. This is the value that I'm casting from. This is like the simple case. It has the ability to take arguments, but by default, casting operators should not need arguments. Yeah, I did not see that it's a method. Hold on, it's a static method. Static operator. Which means that it's like not even like what do you cast into an integer then? Here, nothing. Isn't it supposed to be a member method? So like because I want to have access to my members here to know how to cast the foo into an int. Non-recursive, not found name. Not recursive, not found G. Wait, hold on. I did not find G. I did not find G. I did not find F as a result, and I did not find F again. Is that what happened? Well, I mean, it might be because of the inner block. Because hold on. I think it kind of makes sense because I'm trying to find G over here in the body of the function f when I'm compiling it. So inside this body, obviously G is not defined inside the body, it's defined outside inside this recursive block. So that kind of makes sense. Let's say found name in recursive is this self-recursive. Let's try that. Right, so I found G in recursive false, and I found X in recursive false. Wait, hold on, I found G in recursive false. I found G in recursive false. Wait, what? G is defined inside a recursive thing. Right? Maybe I'm making a new scope in some places where I don't need to. Usually methods defined in static can be considered as namespace functions, but also in certain cases they just re-implement methods parent them. Yeah, but what does it mean to have a static int function? What do you cast? Like what do you apply it to? How do you use that method? I understand what a static method is. How do you use this kast operator? I thought you would have a value of foo and you would say something like int foo. Just the usual way of casting, C and C++ style cast. Yes, but like in order to cast something, you need to have a value, and this is a static method which doesn't have a value, which means that what do you even cast? Like the usual way of casting is having one value and casting it to another type. It's get invoked when type is casted to that type, yes, but like in order to invoke it, you need to have a value of that type, not only the type itself, right? Or are you saying that this is going to work if I say class foo without having an instance of a class foo, and so I can cast the class foo itself into an int? Is that what it means? I can cast the type, not the value of that type. Да, чуть попозже. Hold on. I'm confused right now. What is happening? Scope new. Let's maybe see enter scope. Enter scope. We do enter scope in the then. Oh, we do enter scope in the then. There you go. Do I need to enter the scope in the then? Because I think it's literally the same scope here. Right? I need to like not have these. Found G in recursive is false. Well, compile it then. Definition. Yes, you could do that. Can you give me an example? Because I have never seen the casting of the types. Because you cannot treat classes as types as values, I'm pretty sure. Or in C++. Can you show me an example? C++ cast class type casting. C++ static operator. Like what does that mean here? Static operator. Introduce static versions of the operator this and that. So what does this mean? The motivation for static operator and then consistency this was to allow making those operators static, to allow SAB not have to require the extra object parameter and simply hope optimized out. So what is like ignoring the value? This name of the function is operator. It's not this, as this isn't the way to call it. Is the way to call it. So you still call it on an instance, but the instance is not actually being used. Or you call it on the class itself, which allows you the syntax you originally wanted. Okay. And that is also only like special stuff for the So like I'm guessing that the casting works the same way, even although you don't really like construct the type in this case, the struct or a class. Okay. Yeah, okay. I guess we can do the same, but we actually treat these as values. So we can do more things with it. Enter scope. Exit scope. Why does it say found G in recursive false? Like, that makes no sense to me. Enter recursive. Is this being used? It is being used over here. Enter recursive scope. Is it because no, I didn't enter. I didn't make a recursive. Right? Let's try this over here. Tracing, trace, entering, scope, entering, recursive scope. Maybe not trace. Trace. Let's just do info. Shit. Trace. Hello? Tracing. Trace. Info. Exit scope. So I only entered scope once. I never entered the recursive scope. Oh, wait, hold on. I know why. The recursive scope, like I was only entering it in the interpreter, right? But in the compiler, macro struct, this one, right? This one, the body needs to be compiled with the recursive scope here. So self interpreter, enter recursive. There you go. Self interpreter. It feels like really weird that I could not find. Like, why is it not deadlock though? Hold on. F is not found. I mean, doesn't this mean that I was just introducing it in the That's very weird. Hold on, I don't understand this. I don't understand what happened there. Now you see over here we are deadlocked. Trying to call future here. And there is nothing to deadlock here, actually. It's because I cannot find F, right? This one specifically. This, it compiles, but then it complains that this is not a function, but a nothing. I cannot call it, which makes sense. Hold on. Let's try again. Let F is high. F. This returns high. Let F be X into X. F. That works. Let F into native print. Works. Let's try. So let G be A. Am I trying to achieve recursion in anonymous functions? Yeah. It was already working before in my previous implementation. I'm just like doing it a little differently this time. Let f is G, f. That works. If I say let G is X into X, this works. If I say let F is X into GX, then it works. Then it works. Recursive does not work. Okay, so now recursive does not work, but recursive works. Not recursive works. Can I use the normal brackets here? Remember. Yeah, I can. So if I remove this recursion, then we say, no, hold on, f is not found. Wait, this is literally the same as I was just testing. No? At line number 5 over here, this one. G. This is not found. Hold on. At line number 5, so still the same one. Okay. Let me try this again. In the REPL. Right? Let G is high. Let F is G. F. This does not work. Okay. So I guess the reason it was working is because like it was found in the outer scope because I'm inside the REPL. Yeah. Like I need to actually restart this thing. Okay. Let's try again. Let f is x f. This works. Let's try this inside a scope, right? I guess. Cool. Let x is x x. This works. What does not work? Let y is x. X works. Let y is x. Y does not work. So it is becoming lost. After here. What if I do this but without a scope? Like this. And it still is not found, alright? So what happened? What happened? Why is not found? It also says that, yeah, I did not find it. Yeah, that makes sense. I did not enter any scopes. When I say the let, macro let the way this works. I guess it doesn't matter. The macro then is the one that matters. So I have the A, and then we collect the bindings and we insert these, right? Let's see. Tracing info. Introduced. Oh wait, hold on. Collect bindings does not introduce this thing. Wait. Collect bindings. Like bindings tells me what the things introduce, right? Collect bindings. Oh, it just gets, yeah, if it's a let. Sure. Oh, there you go, there you go. I found the issue. I found the issue. If we have a then, A and B, right? There you go. I found it. Then I should say A collect bindings, consumer, and B collect bindings, consumer. There we go. Found the problem. This should now work. Okay. Let's go back to just run REPL on the call future. Got the expected string, got string into not inferred. Yeah, because this is not a function, obviously. Native print. This should work, right? Yeah, this works. If I make this a recursive, this should still work, right? Nice, this works. Now what the recursive thing should allow me to do is I should be able to reference something in the future. Like if G is declared after F, then this should still work. But I entered the recursive scope and then we are deadlocked, right? Well, the reason for that is because well, I'm trying to evaluate this and then go further, right? So the way this should work, obviously, I should not wait over. So over here, when I'm trying to compile the G here, I guess you know what? Maybe like this should still say that it's. I mean, in the future, I won't have like recursive things anyway, so I want this to compile. But let's at least say that I want to construct a function which uses another function, right? This recursive, so like it's the body of a function that cannot be compiled right now, right? So here's what I'm going to do. When I have the compiler macro function definition here, right? So you know how over here, when I see the definition, this is still not going to work, right? Because so you can see over here, I'm trying to compile the body of the function. It says that it cannot find the G, so then it's trying to like wait for G to be available in the outer scope, but we are inside the recursive scope. But then we are waiting for ourselves because I'm over here when I see the function definition in the code, I'm trying to compile and wait for the body to be compiled, right? But that should actually not happen. I should more like spawn the compilation in the background, and then when it's ready, then it's ready, you know? That's what we should do. Yeah, that's what we should do. You know? I think we will have like a custom runtime too, kind of thing. Or maybe I will add an async executor, I guess. That's what I want. Sync executor. In the async executor, in order because I will be able to spawn things there, right? We will have an executor, and I should be able to have spawn. Tick, try tick. So is this thing itself sync and send? I cannot clone it though, but I can store it inside an arc, right? Yeah. Like nothing requires mutability here, right? Sure. Sure. So this means that cast itself is going to have the executor, which is going to be async executor, which is going to be like arced, kind of. New executor arc, new async executor new, right? Yeah. So we go here. No, not here. Oh, missing lifetime specifier. Well, I mean, this is a static executor, right? Static. Doesn't have to be static, but okay. So when I'm compiler over here, I am going to compile the body in the background. So when we have a function compiled, this is going to be an arc mutex compiled function, right? Because an mutex of like optional compiled function, we're going to eventually say that that it has been compiled and populate this, but not immediately, right? So originally we are going to say that compiled is arc new mutex new none, right? And over here, this is my compiled thing. But this thing we're going to spawn. So self executor spawn. But since I want this to spawn, this means that I need to like get rid of the mutability here. Actually, yeah, there's like some more work that I need to do. Shit. I need to get rid of mutability. Feels dank. I mean, it's not going to be too hard. I just need to say something like, you know, that kast is self-clone. I just need to be able to clone myself, I guess. You know, and then I will say that this is the body. I will say that the body is the same as the result type. That result type is result type clone here. I will say that this is equal to that. This is async, something like that. Async move, right? I just need to like be also like over here. I'm spawning something that returns an error potentially, which means that in case we fail in any of our spawn stuff, we also need to tell the compiler error message something. Also, if I don't detach this, then it's going to be broken. I need to detach that, right? Over here I need to map error in the try future x as error. Let's see, panic error. Let's try that for now. So I just need to be able to clone myself and do things. Can I just derive clone here? Let's see, the executor that is going to be cloned is totally fine. Syntax cloned, I mean, sure. Compiler state, and interpreter state. Let's see, compiler state only has the built-in macros, so technically, like, cloning this is totally fine, right? And interpreter has the current scope and built-ins, which technically also is very fine to clone. You know, it's yeah, built-in. Yeah, like this boxed DNFN though, it cannot really be cloned, but we can have the built-ins stored behind an arc, and then it's going to be really easy. Right, arc, new map. Sure, let's do that. Just run. Mismatch types, expected struct, arc, compiled fn. Okay, so now, when I have a function, so let's say maybe compiled fn. How about that? Where we have the arc mutex option. This thing. This is a maybe compiled fn. So public type maybe compiled fn is this arc mutex, right? Type annotation needed. This error is IRE error, IRE report. Borrow of moved value self. Where? Oh, because over here I need not to use self, I need to use kast, right? I need to use the cloned self, which means that this needs to be now mutable. Sure. Borrowed data escapes outside of the method. Wait, what? Oh, because I'm compiling the body, right? The body is the AST that I hold by reference. Sure, let's say that body is body clone. I'm just going to like own the AST instead. Whatever. Body. No. Body AST. Can I clone the ASTs? ASTs do not implement the clone. Okay, let's implement the clone here. I think that should be done. And then I borrow that here. Sure. No field arg on type. Okay, so now over here, when I'm trying to actually call the function, this means that the compiled function must now be for sure compiled, right? And this must now be compiled for sure. I think it's like even like option arc compiled fn is what I want here. So we say compiled when I'm calling a function, then compiled is this function compiled lock unwrap is going to be match lock unwrap. If it is some compiled, then it is going to be compiled. Clone, I guess. This is going to be specifically arc compiled, and I guess, right? And if it is none, then we bail out, saying that f function is not compiled yet. I mean, let's have a panic here instead, because I need to figure out how to do proper error message here. Mismatch types, mutex guard. Oh, because I need to have a mesh reference on the mutex guard like that. Okay, and then body is just compiled. The body is what we are evaluating here. All right, nice. Let's see. So function is not compiled yet. It is what it said. So the reason for that, by the way, the reason for that is because I never had the chance to run the thing that so like I have spawned the compilation into the background, but I have not like I want to wait for it, you know, kind of. You know, sometimes we want to wait. Is the thing. So for that, since I am waiting for this thing, I want to do something like self executor tick. So executor tick is runs a single task. Running a task means simply polling its future ones. If no tasks are scheduled, then it will wait until one is scheduled. Runs a single task, simply polling its future ones. What if I have multiple tasks spawned though? Like I want to tick. Is there like a try tick? Try tick attempts to run a task if at least one is scheduled. Running simply returns it polling once. What does this return? A task was found. Yeah. Okay. Well, the problem is that it can like be waiting forever, kind of. Let me try just ticking it once here and see if this works. Unused implementer of the future. Oh wait, hold on. Tick is an async. Why is this async? What about try tick? Try tick returns a boolean. But tick is async. And to understand what this means. I used the try tick before. I used this executor in my engine. All future. This is supposed to work, right? Yeah, see? So like it found G in recursive scope, right? Which means that this function I think has been compiled successfully actually. But then it says function is not compiled yet. I think the reason it's doing this now, if I comment this out, then it's not even going to find the G, right? Yes. So in the compiler, I just forgot to after the compilation, you know, the body has been compiled successfully, right? I need to store it in the thing, you know. Let compiled is compiled clone, right? And then over here I need to say something like compiled log unwrap replace with the body, replace with compiled function which has the body and something. That's old compiled be this. We are just going to assert that old compiled is none. Function compiled twice. WTF. This is missing arguments. Arguments is this stuff. Yes. Replace with arg and new, right? Because the compiled function is going to live in an arg, and then the arg itself, which is the pattern, has been moved here. Let's just say over here arg type is going to be calculated before over here let arg type is this. Okay, should maybe work now. Okay, there you go. So now now I can call a function that is defined in the future, right? Now I can call a function that is in the future. Let's see if the actually recursive closures work. I'm not sure. Well, I mean, this has an ifs. I don't have ifs yet. What I can do is like infinite, like printing. I need to implement the minus, the more than, the if, right? I mean, it's not that hard. It's not that hard. All I need, and also like the useSTD does not work yet. They just have an infinite loop using two recursive closures without the ifs and everything. It should work. All future. Let's just say that over here, so the body of the function s is going to call the function g, but only after we say print s and then call g, right? Something like that. Print is native to that, and then g is going to be, they have achieved a lot. Hello, Bigorley. We did indeed achieve a lot, I think. I mean, we have functions. We are testing the recursive functions. Print inside g. Print inside f. gs fs, right? So like these, so g is calling f is calling g recursively, and we are telling we're like that we're inside the things, right? Okay, I am inside f, then I'm inside g. And then we, and then nothing happens. Wait, what? I have already compiled stuff. All that is left to be done is evaluating. I think it's a deadlock because I'm using the mutex. Actually, yeah, I think I know. When I'm evaluating the thing over here, the lock. You see how I'm locking the compiled function, right? But I don't need to like wait, hold on. No. I'm locking it like that's literally why I stored it in an arc, so that I don't hold the lock around for a long time. You cannot focus anymore because you made enough progress. What are you working on? So I'm trying to call f again while I'm inside calling f. So there is definitely some lock that is happening. That has a deadlock. None of the locks should be held for a long time. Not across the await point for sure. Working from home, make a Joomla dynamic card module. Basically, you click a menu item and it takes the data and creates clickable cards. I don't know what a Joomla is. Content management system. Try it, it's free. Is it written in PHP? Something. That's all I know about it for now. Free and open source content management system. I don't even understand what it means. Computer software used to manage the creation and modification of the digital content. How do you guys debug deadlocks? Do you guys have deadlocks? How do you debug this again? Lock. Like I need to find all the references to the lock, kind of. I also like go to references of the lock. Oh, it does work, but I see all the references in the index. I want to see the references in my own code. Yes, that works. Get root. This is not async, so that's fine. It's not async, so that's fine. Not async, not async. When I do the autocomplete not async, that's fine. Insert not async. This, when I'm doing a let, I don't have any await stuff here, so that's fine. This I specifically clone out from inside the lock so that I don't hold the lock for a long time. This is the same. It's going to be locked immediately. This from the outside. This from the outside. This lock is only for this small if, so it should be fine. And that's it. Wait, hold on. No, hold on. It's not a thing. Let me try doing this. Let me try doing this. Since I am trying to evaluate this thing, let's do tracing debug. Evaluating expression dot show short. It's going to tell me what exactly am I trying to evaluate right now, and to have the debug though, right? Rust log is kast debug. So I'm trying to evaluate binding s. Is the last thing that I have seen. And I am inside a recursive scope. Oh. Oh, I see. I guess, wait, hold on. If I'm inside the interpreter. I should never enter in recursive scopes. It's the interpreter, it's going to... Like, we are... Like, this should work differently. And to redo my scopes. This is weird a little bit. We just enter scopes here, not without being recursive. Wait, hold on. But this scope has been closed already. Hold on a second. No. It doesn't matter. It does not matter. I'm trying to find the variable s. No, hold on. The variable s has been found. I'm evaluating the binding. Hold on. Let result be that. Okay, result. But let's do tracing debug. Finished. Evaluating expression show short. Tracing trace. Result is result. I finished evaluating the name, right? But yeah, I'm trying to call function f with s, right? So I am in the process of evaluating the call expression at the line 13. Line 13, this one, right? So I'm trying to do this. So I have successfully evaluated what f is and what s is, right? And then we locked for some reason, right? I mean, that makes sense, but it still doesn't. Expression call over here, right? I have successfully evaluated this. I'm trying to actually evaluate this. Is it because the executor tick await? This does not work, I guess, because await means that I'm waiting for the thing to work. Let's do just try tick. Try tick. Like so what actually needs to happen here? I need to like tick the executor as like not once, I think. But yeah, we did overflow the stack though. We did overflow the stack. Tracing inform. Let's make this. Can I have the never? Trace. Sure. Info trace. This also should be a trace. This also should be a trace. Maybe these logs can be completely deleted. Let's see. Let's not have any logs anymore. So yeah, there you go. We have recursive functions. They work. Recursive closures. Debugging deadlocks is always fun. You always validate your logic visually. Yes, I'm 100% releasing the lock in all cases. The problem is coming from somewhere else. 1 hour passes, then, oh, in this case, it's not being released. Wait, what was the issue? It's not it wasn't a deadlock. I mean, it was a deadlock. Executor ticking the executor. Like, it's just like I need to understand what exactly needs to happen here. Executor tick. Right? So ticking means that running all the background tasks. So right now I'm still running on a single thread. I'm spawning async tasks, not threads, right? So in order for like the background compilation to continue to do the work, I need to like tick a little bit. If I do something like while try tick do nothing, this is still going to deadlock. No, hold on. This is not deadlocking. What does try ticking actually do? Oh, wait. Hold on. I understand. Wait. I don't understand, actually. Wait. Why does this work? But executor tick await does not work. I think I don't understand this tick method. Let's take a look. Docs, async, executor, tick. Runs a single task. Running a task means simply polling its future ones. Like, why is this async? If no task is scheduled, when this method is called, it will wait. Oh, it will wait until one is scheduled. Oh, I see. So like, if I wait for it, if I await, then it waits until one is scheduled, right? So if I have if everything has been done, then it's just going to wait for another one to be spawned. So yeah, okay. It's so weird. Why would I want to wait until something is scheduled? But try tick attempts to run a task if at least one is scheduled. Running a scheduled task simply means polling future ones. So yeah. So I'm just like polling the future until it's completed, basically. Right? So over here, this while is potentially like going to run forever. If none of the futures can make any progress, I'm going to keep polling them, right? So my question is, does it try to poll the future, the tasks, even they have not been if they were not awoke or something? Let's take a look at the source code of this. This is from the small runtime. Try-tick, self-state try-tick, function try-tick. So we pop from the queue. If there is nothing, then it's full. So I'm assuming that the queue is the queue of tasks that have been that have been like just spawned, or if something was pending previously, then it goes back into the queue when I call the wake method, right, on the waker. So when it's ready to make more progress. So I think if I do a while try tick, this should never deadlock still, unless we have a future which returns, which is like waking itself every like on every pull. I would assume that that's what it means. I think the documentation could be improved here. Anyway, we have the mutually recursive closures. As you can see here, we overflow our own stack by doing that. I can also, I guess, just have a recursive closure normally, right? I don't even need to call the like to call G, right? I can literally just call myself here, right? That's what we want. There we go. We can call ourselves, and it works. With a non-recursive, it should not work. Okay, yeah. And then we can like have a syntax for defining a single recursive closure easier, I guess. So the idea also here is that this recursive block is going to be compiled into a single structure, which is going to be like dropped once the structure is dropped, which means that I should not return anything here, but all the bindings, yeah, were like fields of this struct, basically. Or like public fields of this struct. And this is like a self referential struct, something. Instead of returning this f from the outside. The recursive thing was a little different, yeah. Or does this make more sense? If I just have a recursive piece of code where the bindings can refer into something from the future. And then this is just the result of this block. No, I think this does not make sense, because like I will want to have a borrow checker at some point. So the recursive block acts like an arena, basically, that everything I should not be able to hold a reference to anything inside of it if I have dropped the arena object itself, basically, right? Which means that the recursive block, the result of this expression should be like the this, we call it arena, and then we call arena.f thing, because that's, yeah, something like that. I guess I'm going to keep this for now, though. But yeah, it will stop making sense once I have the borrow checker. But good progress anyway. I'm going to commit this. Async compilation. Mutually recursive closures. There's a bunch of issues, though. Let's try to make sure that this is going to not type check, right? So let's say that inside of this function, let's say that inside of this function, so that it doesn't compile, I'm going to call. I'm going to say that that s is I don't know. Let's say that g is a function that takes an int32 instead, right? Because like I'm obviously trying to call it with a string, so it should not type check. Int32 is native int32. This should not work, right? But this deadlocks because we have an error, right? We have an error. Let me see. Wait, hold on. Why do we do that? Panic. Did I not panic over here? Maybe panics are ignored in the executor or something. Does it catch the panics? Let's try tracing error. Because I'm pretty sure we should get to this panic here, but we don't. Okay, what actually happens then? Is that a saber? Hello, hello. If it doesn't compile, then we still deadlock. I need to go eat. And so I might just end the stream then, and then we'll like I will maybe fix some bugs off stream, or maybe I will do it next time. Let me just see if I can fix it in 5 minutes. So function compile. How about you can fix it in 5 minutes? Famous last words. I didn't say that I can fix it. I said let's see if I can fix it in 5 minutes. All right, that's different. Tracing, debug, compiled, st show short, tracing, debug, compiling, st show short, dot here maybe. So I'm compiling the type ascribe at 11.12, 11.22. Call future. Oh, wait, hold on. I see now. I see. So here's the thing, right? It's the body of the function that I'm compiling lazily right now. I mean, not lazily, but like in the background, basically, right? While going forward. But in order to evaluate what an int32 means, I need to evaluate this this thing. What is int32? And as you can see, int32 is defined outside of this recursive block, which means that but what if the int32 was defined here, right? Because I'm inside the recursive block, every single thing is potentially referring to something from the outside, right? So how do I solve this? How do I solve this? Like I think I also I think I think I want, you know what I want to do actually is I need to change the way I do the recursive things. Instead of saying let f and let g, I should only be able to do something like let like something. I should have like basically recursive thing, which you know, like I say f is, let's rewrite this so that you can understand what I mean. I do this, and then I do that. So we construct a recursive structure. Just like I was saying, the recursive block is supposed to be a structure anyway, right? So we have two fields, f and g. So here's the idea then. Instead of like evaluating this as like one by one thing, we are going to construct these things at the same time. So we're going to know immediately. So like basically what I'm saying is that I want to know. I don't need it to be async then. Hold on. I will be able to remove the asynchronous stuff then, I think, completely. No? Like if I do something like this, then I know like I can parse this thing. I can see what are the fields that I have, and I'm going to um like compile this, knowing what we have in the scope, kind of, you know? So previously this was like imperative code inside, which allowed me to construct the things. I mean, it's kind of, do I want this still to be able to do that? Like, I kind of think that it still is nice to be able to do this, because otherwise you would need to rewrite your code sometimes, right? You realize that you need some a little bit of recursion here. You can no longer just add a recursive annotation on on some scope, right? You would need to change these things into being fields. I can do what? First half of stream editing async, second half of the stream removing it. Yeah. Um ding, 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 ding. I think the pattern should also be compiled lazily, actually. You know what? This thing should also be compiled lazily. Like, I didn't support recursive type definitions in my previous implementation. So, you know, if I had, like, in the OCaml version, I had recursive closures, but I did not have recursive types. Like, if I say that, that type, I don't know, tree, right? Tree is tree is either like is either a leaf or a node where I don't know, left child is tree, right? And right child is tree, something like this. Like I could not do that because yeah. So this would also need to be inside a recursive definition, right? And especially if we want to have like mutual recursive types, this would also need to be inside the recursive stuff. But doesn't this mean that the type definitions are also going to be lazy, similarly to how function definitions are lazy? Doesn't this mean that everything is lazy? Don't we make everything lazy? Every binding, you know, when I see something like let when I see let pattern be value, don't I just calculate the value lazily when I actually need it? I mean, not really. That's not what I want. I think it depends on the type of the thing. On lazy everyone approach take a lot on memory. I don't know. Have you tried Haskell? Haskell is in Haskell everything is lazy. In Zig everything is lazy. I guess Zig is more. Zig is closer to what I'm doing here. Zig has comp time and their compilation is also lazy. It's about the compilation, not about the evaluation being lazy. By the way, in Haskell you can yeah, you have the evaluation being lazy, which sometimes leads to a lot of memory. So you need to sometimes think about that. From what I heard, not that I'm a Haskell expert. Like it just depends what do I need immediately and what do I not need immediately, right? If I say that g is a function like that, then I don't need to know about its type yet technically, right? So why am I doing this eagerly instead of doing this in the background, just like the body? What are some other things that could? I mean, eventually, I want more than just like recursive closures and types, right? But I don't think I'm ready for like self-referential structures of like the other ones. Let's just do the compiler. Let's just do the type to be lazy, right? So we have the macro function definition. Also, I kind of think that I think that what do I think? Like, yeah, I'm also like calculating the result type immediately here. Oh, like there is the tasks that I spawn to run in the background, kind of like the compilation of function, right? And there is the normal compilation process, which should never be deadlocked. So like I kind of can I can sometimes know that I'm going to deadlock, right? And I can exit immediately, kind of, you know? So for example, over here, I'm spawning the thing, right? And since I'm spawning this thing here, since I'm spawning this thing here, how about I say cast.spawned is true, something like this. Spawned boolean. Am I a background task? Spawned false. So only something in the background should be able to await. Everything else should kind of be sync, you know? So the only thing that is actually waiting for things is me getting the identifiers, which is over here, the scope. I should have get, and I should have get let's say let's have this get like do await, I guess, is a boolean. Like the only the only place where I am actually awaiting something is this, where I am doing the notification, right? So if not do await, then I also am going to break basically here. Wish someone wanted me as bad as Robert Pattinson wants to get banned. What did he say there? Guy and a girl are in the same programming class. Out of nowhere, a guy reaches over and grabs the girl's breast. Disturbed, the girl slaps the guy's cheek and says, "What are you doing? Those are private." But we're in the same class. Let's call this get impl. We're going to have a function, async function, get async self name stir option value. This is going to be self get impl name await true. And then just a normal function, try, I don't know, get sync self name stir option value self get impl name false. And since this is still like async, technically we do like let future be this. I need to poll this once. Steady pin in future poll poll. Ah, fuck. I need to like poll context std task context from waker. How do I poll the task once manually? Like because I want to like make sure that it is immediately ready, right? Rust poll future ones. I mean Rust assert future is ready. How about that? How do I check if the future is immediately ready? Call some async future is ready. So we pin it as mute now or never. Now or never. Future dot now or never. So this is from the future script, I guess, right? That's what we want. Now or never is an option. Okay, so unwrap because like the implementation here is done that way that it should be now or never. I just inline this. Right. So over here, when I say the get, I will say that whether it's saying, hold on. I want to have this public. No, I don't want to have this public. Yeah, sure, let's give it public. Get impl. So whether we are async or not, based on whether I am spawned or not. Now this is inside the interpreter. Git. Spawned. 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 False. Spawned. That's true. I don't know. Let's do something like that. And 32 is not a type. Okay, nice. It actually works. This just needs to be const, so that's available to the compile time. It's not a runtime value, it's a comp time value. So we do this. Function is not compiled yet now. Okay, so now we see that the function is not compiled yet, but the reason it was not compiled because the compilation crashed. Right? That's why. Because we have the type checking issue. We expected an integer, but we got a string, right? Because yeah, this should be a string. So if I do string is native string, then it would work. Nice. Okay, so this works basically like over here. Like I can only right now basically refer to something from the in the future from inside the body of the function, but not from anywhere else. If that makes sense. So for example, in the type definition here, I could not like say that this is f. Right? Okay, kind of. Lazy. All right, let's see. Only wait in recursive scopes from spawned tasks, something like that. All right. I probably need to make this code better though before continuing. Like I said, I need to go eat. This is good progress, I think. I'm going to end the stream. Making a risk-v assembler. This person is basically making their own language too. It's just an assembler though, I guess. Assembler for risk-v, VLIW. I have no idea what that means. I don't know. Looks kind of related to making compilers. So let's go here. I like the sounds of keyboard. I should probably set up my microphone so that you guys can hear my keyboard. Somehow, not sure. Or I should type really angrily. How do you know it's a person? This person is not a real person, you think? You think it's fake? I don't know. Well, let's see if they talk when we raid. See you guys next time. Bye.